Okay, perfect. The recording is also on. Let's start now. It is muted, Husni. Check and see. I think it's a mistake to unmute. I modified it now. Okay, let's start. Tidin, tidin, tidin. Good job, Nafa. Yes, Jamila, yeah, seeing it today only. I regret it, no? Okay. Alhamdulillah, all good. Tin, 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 tin. Yes, walaikum salam. And hello. Walaikum salam. It's two different sessions. Session one is only for grade. Session one is for covering grade 10 parts. Session 2 will be covering only grade 11. So if you're a grade 11 student, you're supposed to join both the sessions. Yes, Zoha. Yes, it's possible. So what do you call? I'll be posting the recording in the channel once the seminar is over. Anyways, for those who don't have the record, those who don't have the tute, I'll share you the tute in the chat, so y'all can just check that out. And once the seminar is over, I'll be sharing the recording as well in the channel. So just make sure they're in the channel as well so you can get the update as soon as it's available. So let me write that as well. Okay. I posted it in the chat. Um, Actually, I was supposed to send you all the paper a bit early, but then there was a small delay. And so if you all can do the paper, good, but not compulsory. I'll be asking the answers in the chat. So I want you to I'll be asking the answers in the chat. So based on that only, what do you call? I will be this one. I'll be teaching you all. It's better if you all can have a full scale paper, at least like a A4, like a CR paper, 4 sides, because while teaching you all, I'll be giving like a rough note. So if you have a like a PDF, I mean, if you have like this one, if you have like a book with you, which you can write, or at least what do you call a middle page, a book's middle page, like 4 sides, then it will be easy for you to write down the notes I give you. Because while teaching, I'll be just roughly giving you all some notes as well. So it's better if you can note them down. Anyways, let's start now. Didn't, 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 and didn't. Yeah, all good, Alhamdulillah. Okay, modify it now. What do you call Rishta is better now? Yes, you all can. Those who have the, I mean, those who come from a recap class, you all can use the same writing book. Yes, you all can use that. Actually, better if you all use that. So your notes are organized. Okay, let's start. Inshallah, Mohad. Amna, I have already sent it in the channel. Just check the channel. The grade 11 tude is also there. Like I have put session 2 grade 11 only kila. Check the channel. It's there. Okay, let's start. I hope I have clarified all the questions in the chat. So let's start now. So, like I told you a while ago, how this seminar is going to work is I'll be discussing a paper, and using that paper, we'll be learning the theoretical parts. So, while doing this what do you call questions, I might not give you all separate time to write, but while teaching you all, I might write down, okay, certain stuffs. So, while I'm what do you call writing itself, mostly I'll be answering others' doubts parallelly. So, if you all want at that time, you all can write, or parallelly with me also, you can write. It's not big notes, it's just short. What do you call? I'll give the notes shortly, right? We didn't get what that is all a great 10s, man. Only grade 11's got the book. Anyways, let's start now. So we're discussing a third term paper, Southern Province paper. I think it is 2024 or else 23. I'm not exactly sure which year, but yeah, let's start now. The first question: write two features of a quality of information. Okay, you all learned about quality of information. If you all can remember properly, this thing called quality of information is something you all learn in your grade 10 lesson number 2. Sorry, lesson number 1, where you learn about data and information. That is where you'll actually learned about this. Okay. Now, how many qualities of information have you all learned? Basically, all of you answer in the main chat. Don't send individual chat answers. If you take information, how many qualities of information did we learn? Hey. You don't have to, what do you call, repeatedly send the answer. Whether you send one or 500 times, it's the same thing. Perfect. Okay. Correct. That's fine, Alpha. Exactly. Okay. We have the what do you call the five qualities of information. So the five qualities of information are when you have accuracy, that is where you go and check is it the information correct or not. So if your information is a correct, like if it's correct, then that means okay, you are good to go. What do you call your information is a good quality information. Second thing is, for example, is this information relevant? We call this relevancy. Like for example, if I come and tell you all the timetable for let's say oral exam, that's relevant for y'all. But if I come and tell you all the timetable for A-level exam, is A-level exam timetable relevant for y'all? No. So that is a, what do you call that information is not a good quality information. Even though that's a correct information, that is not a good quality information because that information is not relevant to y'all. Another quality of information we have is, let's say, for example, timeliness. This is where your information is being updated. Now, for example, what do you call? You all must have heard this thing called old syllabus and new syllabus, right? Now, if you take, I think actually you all should have got the new syllabus, I think from this year or something, but there's a small delay. But leaving that thing aside, normally if you take your O-level syllabus as well, in your textbooks, we have old syllabus and new syllabus and all those stuffs now. Currently, if you take the syllabus we are following at the moment, the syllabus we are following at the moment, that was for, I mean, the first oral paper in that syllabus is in which year? Which year has a first oral paper as per the new syllabus? Perfect. New syllabus which you all are learning, the first oral paper was actually from 2016. Now, if I go and discuss a 2010 paper with you all, is that something what you called that sometimes the subject might be relevant? Again, I'm doing ICT paper. So ICT exam, I'm doing ICT paper. So relevant, it might be relevant to you all. Okay, the subject might be relevant. But sometimes the content might be outdated. The content might be, for example, old, or the content might be too advanced, not relevant. Now, what you call the content might be different sometimes. Okay. So what I have done here is I'm discussing something old instead of discussing something new, right? So timeliness is talking about something about where information is being updated. Then how do you call the quality of where your information is going to be, what do you call, it's not half. Like for example, let's say if I want to find out the average in a classroom, let's say in a class, there are 50 students, and I want to find what is the average marks. Without getting all 50 students marks, if I get only 30 students marks and find the average, what quality am I talking about? There are 50 students in a class. But when finding the, what you called, I'm gonna drop your answer in the main chat. I again told you if there's any direct questions you have, drop in the personal chat. The general answers, drop in the group chat, the main one. Yes. So okay, when I'm finding the what you called this one, when I'm finding the average marks, I have to make sure I get all the students' marks in a class, not only half of the class, right? So if I'm going to get only half of the class, then I'm talking about the quality regarding completeness. So completeness is where you make sure your information So the data you obtain to form the information is that the data you obtain is complete. Okay, that's what completeness is talking about. So these are all talking about. I mean, if information have all these categories, and the last one is cost effectiveness, right? Mostly cost effectiveness means like to obtain information, you need something, right? What do you need? Without something, you can't create, you can't form an information. I told you a while ago as well. What do you need in order to create information? Perfect. You need data. Okay. The data has to be what to form information? The data has to undergo something, right? It has to undergo what? Data has to be what to form an information? Perfect. The data has to be processed. Only if the data is processed, you can form information. Exactly. Okay. If the data is processed, you can form information. Right. Now, in this case, what happens is to obtain this data, you might sometime have to spend some, let's say, what you called certain things. For example, you might have to sometimes spend money, or sometimes you might have to spend time. Mostly, these are two things you have to spend to obtain data, either money or else time. So, cost effectiveness is where to obtain the information, the time you spend or the money you spend is basically not going to be a waste, but it's going to be actually useful. It can be energy as well. Yes, time, money, as well as energy as well. Like, for example, imagine I gave you all an assignment to do, and in that assignment, you all are supposed to find out the area of Sri Lanka. Okay, if you take so not area of Sri Lanka, let's say circumference of Sri Lanka, which means like if you take the whole outline of Sri Lanka, what is the distance? Now, are you going to take a measuring tape and walk around Sri Lanka? Is that the method you're going to follow to obtain that answer? Now I'm asking what is the area of Sri Lanka? So what is the like perimeter of Sri Lanka? Okay. If I ask her what is the perimeter of Sri Lanka, are you going to take a measuring tape and go and find it? No. Where will you find this answer from? Exactly. Some of you all might use Google, some of you all might use ChatGPT, some of you all might go and go through books, your geography books or something. Basically, you're going to go and find it from a place where it's already published. Okay. So you obtain the information, fine. The information you're going to obtain, when you obtain, you don't have to spend unwantedly. Don't waste. It's not that no certain information you have to spend time and effort, but don't waste time and effort. That's what it's talking about, the cost effectiveness. Okay, so effectively spending money, time, and energy to obtain your information. Okay, that's what these five qualities are talking about, and these are the qualities of information. Anyways, if you have any questions, drop in chat. This is not relevant for this question asked here, but when you take data and information, another common question you all can get is something called as now, this is qualities, no. Other one they might ask is characteristics or difference between data and information. When you take data and information, tell me out of both of them, who is meaningful? When you compare data and information, both of them are not meaningful. No. Only one of them is meaningful. Who? Correct. Information, we can one of the what you call qualities of information is that. So, in one of the characteristics of that is it is meaningful. Okay, meaningful, and this is the opposite, meaningless, right? Then when you take in what you call data information, which one is actually processed? Correct. This is processed and that is unprocessed. Okay. When you compare data and information, which one can be used to make decisions? Perfect. You can use information for decision making. We normally don't use data for decision making. Do you not? Because unless you process it, you can't conclude any decisions. Then which one is independent? Which one is independent? Independent. That means it can stand alone. It is not what you call without that also without it can be alone technically. Correct. Data is independent. What do you mean by independent is without anything you can create, you can what you call like to get a data, to form a data, we don't need anything else. Okay. But information is dependent, right? Without something, you can't form information. Information is dependent on whom? Correct. Information is dependent on data. Without data, you can't form information. Okay, so these are some characteristics of information, data and information. Apart from this, you can also tell that mostly who is organized. This is not, it depends on the situation, but most of the time, who is well organized? Is it data is organized or information is organized? Correct. Normally, when you have all the what you call, if you take information, information is more organized and data is mostly unorganized. This is a depend. It depends on certain situations, but mostly data will be unorganized and information will be organized. So once you organize your data, basically it becomes information. Simple. Anyways, these are some differences between them. That was not relevant for the question, but for the first question, if you had mentioned any of those answers, you're correct, right? Again, I'm telling you all, for those who came late, I'll not be giving out separately notes and all, but I mean, I'll not give you a separate time to write the notes. I'll be just writing it here. So while I'm teaching it, it's better if you all can note them down. Next, second question. The second one is studying what is the data transmission mode used in each of the following function. Sending an email to a person who's in another country, student watching a data transmission. Okay, fine. Before I answer that question, normally if you take data communication is where you can send the data from the sender to the receiver. Okay, where you can send the data from the sender to the receiver using some medium. From the sender to the receiver using some sort of a medium. This is basically what you call as data communication, right? Now, when data is going to travel from sender to the receiver, there are different ways it can travel, okay? Or like in different directions the data can travel, right? One thing is the data can travel in a one-way direction. That means only from the sender to the receiver. If the data is going to travel in a one-way direction, how do you call that data transmission mode as? That one way, only from sender to the receiver? Perfect. If data is going to travel only from the sender to the receiver, we call that as simplex mode. So in simplex mode, what happens is the data travels only. I'm going to call this as sender as S, receiver as R to make the work easy. Okay, so here only from sender to the receiver, the data travels. Okay, now in terms of data, it can travel both the ways as well. It can go from sender to the receiver and come back as well. Okay, now in that situation, there are two types. Okay, one is there, the data can go from the sender to the receiver fine, but apart from that, okay, apart from that, the problem is when the sender is sending a message, the receiver will not know what is the sender typing. For example, if the sender is typing something, whatever, the sender receiver will not know what is he typing until he receives it. After he receives it, only he will know, "Ah, okay, this is what the sender was typing." And after that, only he can reply. So he can reply after he gets the message, not while the sender is preparing the message. Okay. He has to wait till the sender completes the message in order to give a reply. What do you call this type of communication as? Perfect. That type of communication we call as a half duplex mode. So half duplex mode, both sender and receiver can communicate, but the difference is only one at a time. Now there's a third type of communication where both can speak at the same time, which means while the first person is speaking itself, the second person can go and interrupt and be like, "Hey, wait, listen to me." And he can interrupt that first person's communication. So how do you call that as? Perfect. That's called a full duplex mode. So this is the three modes of data transmission. Okay. Is qualities and characteristics different? Yes. Actually, the correct word should not be quality of information. The correct topic, even though in the textbook and everywhere it's giving us quality of information, the correct word should be qualities of good information. Okay. So yeah, here these are the qualities of good information. You can like classify information as a good information and bad information. Not the good dash, there's another name for that. I'm not exactly sure, but it's like good and bad. Got it? These are qualities of any information, but this is qualities of good information. Okay. So yeah, out of these answers, if I mention anything, these are basically the data transmission mode. Now, based on this, let's answer the question. Sending an email to a person who is in another country. What type of data transmission is this? You're going to send a mail So when you're sending a mail, is it a situation where what you called that person can't reply? No, he can reply, right? So in that case, what is more suitable for this? Yes, it is not simplex. The reason it is not simplex is because the receiver can reply. But out of half duplex and full duplex, the most suitable one here is going to be half duplex mode. The reason is because what you called until the receiver gets the email, he will not know what you sent. So after he gets the email only, he can reply back. So if he has to wait till he gets it, that's basically half duplex. Student watching a video downloaded from eTaksala website. What is the type of communication here? You're watching a video from the eTaksala website. What is the definition for data transmission? Data communication. That's what I said. The data transmission, data communication, both are same. The data going from sender to the receiver. That's what I call as data transmission or as data communication. Okay. So normally when you're watching a TV, let's say for example, so you're watching a video, you have the video here and you have the human here. Now, if you take this situation, what's happening is you're obtaining some information from the video. You're learning. Now, if you take a look now, for example, you're learning something from that video. Okay. Now, while you're learning in that video, can you reply back? So, or can you like, reply with certain questions and get those questions clarified from that video? Can you reply back a question and get them clarified? No. Now, for example, if you take the Zoom meeting, okay, we have a Zoom meeting going on, right? Let's say y'all are joining the Zoom meeting, right? Now, while you're joining the Zoom meeting, you all can ask me questions. Fine. But let's say there is a student who is watching the recording of this Zoom meeting. Now they are watching the video, fine. So they are getting the information. Now, I'm there in the video, so they're getting the information from me. So while they're getting the information, but can they reply back to the video, not to me, not to my WhatsApp message? That's a different story. But can they reply to that recording they're watching and get their doubt clarified? No. So it's just a one-way communication. So if it's a one-way communication, then it's going to be a simplex mode. One-way communication is simplex mode. So two-way communication is only half duplex and full duplex. The difference between half duplex and full duplex is in half duplex, even though both can communicate, the receiver is there, right? The receiver should wait till the sender finishes his sentence. Then only he can reply. Full duplex is both can, I mean, the receiver can reply before the sender completes his sentence. Okay. So for example, if you take call conversation, in the call, actually at the moment we're having a conversation, right? The call. It's kind of a video call, even though you all are chatting and I'm responding. No, I am the sender here. I'm giving you all the information. Should you wait till I complete the sentence for you all to reply something in the chat while I'm speaking? Like, let's say I'm defining or what do you mean by qualities of information? Okay. Did you have to wait till I finish the whole thing to reply back? No. So that is full duplex. You can interrupt while I'm speaking. If it's half duplex, let's say both of us are chatting. But the same thing I'm speaking, if I'm typing, if I'm chatting in the chat now, while I'm typing, do you know what am I typing? Let's say I'm typing in the chat. While I'm typing, do you know what I'm typing? No. You have to wait till I finish typing. You have to wait till you get the full information. So only after you get the full information, you can give a reply back. Or only after you get the full message, you can give a reply back. Right? So that's what you call as a half duplex. So half duplex is you have to wait till the full thing is obtained. Full duplex is you don't have to wait till the full thing is obtained. While it's in the half itself, you can reply back. Got it? Okay, so these are answers for this question. Next. Identify the following devices. More, I'll give you share in the PDF later. Chatting is half duplex. If both of you are chatting, it's half duplex. That means if I'm also messaging, you're also messaging. If both of us are messaging each other, it's half duplex. But here, I'm having a call and you're replying through chat. So it's full duplex. I mean, the communication I'm having is full duplex. The Zoom meeting considers full duplex. I mean, normally, if both of us are in a video call, then it's definitely Zoom, but full duplex. But what do you call if I am going to speak and you're going to reply in chat, then my perspective is full duplex. Why? While I'm speaking, in the middle you can interrupt. But in your perspective, I had to wait till you finish typing. So it's like a mixture of full and half. But normally chatting is half duplex, calling is full duplex. Got it? Sorry. What do you mean by live news? Next. Identify the following devices and choose the relevant words in a list of terms and write them with the labels. Okay. The first is actually a type of printer. This printer is, if you notice it properly, it's used to print housing plans. Out of the printers we learned, okay, this is again relevant to your second lesson. If you take your printers, we can classify printers into how many main categories? Sorry, correct. Normally, we can classify your printers into two main categories. Okay. One of the printer is where inside the printer there is some mechanism that touches the paper. And other type of printer is where it doesn't touch the paper. So if there's something within the printer that touches the paper, how do you call that type of printers as? Perfect. They are called impact printers. Okay. Then we have another type of printer where in the printer there is nothing that is having physical contact. Like for example, imagine for if you're painting a wall, you can take a brush and paint, or you can use spray paint as well. Now in brush and painting, it is getting that what you call the device is having contact with the wall. It's touching the wall. But spray paint, it is not touching the wall, right? The paint is being transferred, but there is not your what do you call machine is not touching. So those we call as non-impact printers. Okay. And then we learn certain examples for impact printers and unimpact printers. I'll just tell you some examples. Tell me under which category will they come? Sorry. We have a printer called as dot matrix printer. That comes under which category? Okay, you can tell one or two. Impact printer is one, non-impact is two. So tell one or two. Okay, this is one, this is two. Correct. Dot matrix printer is an example for impact printer. Okay. Then we have a printer called as the line printer. Correct. Line printer is also impact printer. We have something called laser printer. Laser is actually two. We have something called as a inkjet printer. That is correct. Inkjet is also two. Then we have something called as, let's say, thermal printer. Correct. That's also non-impact. Now, apart from these, there's another printer called as a plotter. It's very huge in size. It's mostly used to print those architectural plans. Like before you build a house, we have those like housing plans they make. No, if you have noticed those plans they make. Okay. To print those, we have something called a printer called plotter, which is actually this actually this is called a plotter. Okay. This is a what type of printer? Impact or unimpact? One or two? Sorry. Actually, plotter is an impact printer. Okay. Plotter is a impact printer. So this is what you call as a plotter. Keep that in your mind. Sorry. Next. What is the second device? Sorry. What is the name of the second device? Yes, Samar. It's called Wi-Fi. It's called router. Tell me, you have heard this word called router, you have heard this word called Wi-Fi, right? Is the word Wi-Fi and is the word router the same? Is the word Wi-Fi and is the word router the same? No, Wi-Fi and router is not the same. Okay, router is basically a device that can emit the Wi-Fi signals. Okay, So for example, now y'all are using y'all are what you call paying for the Dialog or Mobitel or Airtel or Hutch or SLT or people you're paying and what you call a value for something called data or internet kill, you're paying a price, right? There what you're doing is you're paying for those companies to obtain data. Imagine, for example, you in your phones you have SIMs, right? To call, you need money, right? So, for example, imagine you're reloading your SIM. That's why you're paying for those companies as well. Okay. Now you have the SIM fine, but to make a call, if you go for the communication by SIM, with just a SIM, can you make a call? You have a SIM fine, but with only a SIM, can you make a call? Sorry, wait. No. If you want to make a call along with the SIM, what else do you need? And a SIM has for what you call SIM has money. SIM has money. You bought a SIM, buying a SIM, obviously you didn't bought. What else do you need? Exactly. You need what? You have the SIM in your hand, but can you call with the SIM? Can you keep that small SIM and keep in the phone and call? No, you can't. Obviously, you need a phone. So you put the SIM inside the phone and you can take a call, right? Similarly, Wi-Fi is that connection. We say Wi-Fi connection. That's basically that connection. It's like the SIM. If you want to use Wi-Fi connection, or if basically it's the correct word I use is the internet. If you want to emit these internet signals, then you need a device called a router. So what this router will do is router will emit Wi-Fi signals. Okay, so different routers has different capacities and capabilities. Okay, now for example, if you're attending my physical classes, grade 11 physical classes, you all must have noticed there was an issue we had faced in the last week's physical class. Okay, I was using I think four routers, like two hotspots and two in well, the two hotspots, two routers. Colon now two hotspots and one router because that had only one router in Velavata. Okay, so one of the issues we have is the normal Wi-Fi router we have, it has a limit of. Actually, today also before the class was starting, I was searching for routers only. I was even thinking of buying Starlink. There's a possibility that next week's class might have Starlink, but let's see. But you called the routers, there's a issue. The problem in routers is basically maximum around 32 devices, between 25 to 32 devices only. What you called can be connected in these Wi-Fi routers. Okay. Yes, Husni, yes. Maximum 25 to 32 devices only can be connected in these Wi-Fi routers. So in last, if in the grade 11 class last week, we had practicals. And then what happened was we were unable to connect everyone in one what do you call hotspot or one router. They have to connect to multiple. The reason is because these different routers has different capacities. Certain routers can handle multiple devices, certain routers cannot handle. So depending on the price of the router, the features will differentiate. Okay, so let's see for next week's class physical fellows, you all might have a better router. Worst case scenarios, I might get that link as well. Let's see. Anyways, next. So Wi-Fi router is basically a device that can emit these Wi-Fi signals. Huh? It's just like a phone that you can use to call. So like you have to connect the internet connection to this router. Next, what is the third device you have there? It's a type of printer. What type of print? You all must have. I don't think you all are familiar with this printer. I'll give you all a hint. This printer uses heat to print. So what type of printer do you think this is? That's a hint I can give you. I don't think you all are familiar with that picture, but that's a printer that uses heat. Let's see, Aditi. Correct. This is called a thermal printer. Okay. This is a portable thermal printer, to be precise. You can carry it and go here and there, and you can use it. If you all must have seen a similar version of this in if you all go in the bus. In the bus, they give you the ticket, right? If you notice, that looks kind of like this only those bus ticket as well. Okay. So yeah, or even if you go for the shops to do card payments, they have a machine. Same system. What is that fourth one? Correct. Abdullah, go and watch the recording. You'll get the answer. Correct. Stay. Yes, what do you call? This is called the hard disk, right? To be precise, this is not the solid state hard disk, the magnetic hard disk, to be precise. Yes, Zainab. How to identify as laser printer? Laser printers are too big. You don't get small laser printer. That's the first thing. And second thing is laser printers, they use what do you call, mainly from the size you can identify. It'll look like this. I'll show you how a laser printer looks like. But I have not seen small laser printers. I don't know. But yeah, you can't identify by looks. It's very hard. I mean, this one you can identify in looks. Those big ones are the communication. If you go to the big ones, that by the look itself you can be like, okay, it's definitely laser killer. But the portable one, these all I have used, so I know it's thermal. So the smallest one you can have is thermal. Okay, so thermal printer uses heat to print. Next, from Wi-Fi, fewer devices can be connected than the router. It's like you're asking from SIM we can message, but we can't call, right? What I mean by SIM is this thing. Yeah, this is SIM. Okay, this is what you call a SIM, right? This is what a Wi-Fi is basically. Imagine this is Wi-Fi. Okay. Now, if you have this, imagine this is a Wi-Fi route. Wi-Fi, I have Wi-Fi is just a connection. If you want to use that connection, you need a device called a router. So you can connect that Wi-Fi. If you know, for example, there are two ways you can obtain Wi-Fi. One is you can obtain Wi-Fi in a wired way. One is you can obtain Wi-Fi in a wireless way. If you're obtaining a wired Wi-Fi, that wired Wi-Fi connection, you'll be getting a wire basically. Imagine, so basically your Wi-Fi will be this. If someone asks you what is Wi-Fi, you'll be like, okay, this is my Wi-Fi. Now, if you have a wire coming, can you directly use this wire? Can you what do you call, can you search internet from a wire? No, you'll connect this wire to a device. So you can directly connect. Now, certain laptops you can directly connect and use. Okay, now it will not be in this port, it will be RJ45 port. Certain device you can connect this wire directly to your laptop and start using the Wi-Fi. Or else, what you can do is you can connect this to a device called a router. Okay, you can connect that wire to a device called router, and this will emit Wi-Fi signal. So Wi-Fi is basically signal. You know what is Bluetooth, right? Just like Bluetooth, Wi-Fi is a signal. So it will emit Wi-Fi signals. So actually speaking, Wi-Fi is just a signal that is emitted by the router. Got it? Okay, next. Earlier days we got there as two different devices, I think, but it's the same thing technically. It's not a device. It's one thing. Difference between router and modem. Modem is when you want to connect to this one. What do you call? Mostly in fiber optics Wi-Fi, you get modem. If any of you have a fiber optic Wi-Fi, you might notice when the internet is coming from the outside cable, when it is coming from the what do you call? Let's say SLT modem, you all might notice fiber optics Wi-Fi. If you all have, you all might notice sometimes when it's coming from the, it'll come from the telephone line cable. The maker, you have a lamp post, and from the lamp post, they'll take the connection, and there'll be a small device. Okay, and then only it will be connected to the router. It will not be directly connected to the router. The wire will not be directly connected to the router. So that device in the middle is called the modem. This modem will be connected. You have connection coming, right? This connection will be mostly coming from that lamp post, telephone line. So that modem, what it will do is it will connect, it will convert that analog and what they call digital data. That's what it does. That's a different topic. You don't have to know it at the moment. But yeah, modem and router is two different devices that will convert the analog signal, digital signal. You will mostly find this only if you have fiber optics Wi-Fi. Normal Wi-Fi, I don't think you find this modem in your houses. Because nowadays, what do you call Wi-Fi routers has a modem inside it inbuilt, so it does not need a separate device. Okay, but I think mostly I don't know all the brands, but most of the earlier days that was, I don't know nowadays fiber optics they have that. Well, earlier days fiber optics Wi-Fi they had this modem as a separate part. If you have the SLT Wi-Fi, yes, but nowadays mostly routers have the modem inside it, so you don't find that as a separate device. Okay, next. Nowadays you don't get that as a separate device. For most routers. I have never seen nowadays wired routers even has that modem separately. Next. Draw the incomplete truth table given below to your answer sheet and complete it using the following circuit. Okay. I'll quickly give you a rough view of this logic gates, and then I'll go for that question. Okay. Now that question is something regarding logic gates. Regarding logic gates, the first thing you should know is what are the gates we have. Okay. So normally we have two types of gates. One is called basic logic gates, and the next category is something called as combination logic gates. Okay. So when you take basic logic gates, the normal logic gates we have, difference between hub and switch, that is basically, I'll quickly tell it because that is not relevant here. Imagine you have multiple devices you want to connect together in a star topology. Okay. So if I want to connect, or let's say you want to have multiple devices to connect to the Wi-Fi router, right? If you go in the back of the Wi-Fi router, you might notice sometime only one port is there. Let's say one RJ45 port is there. Okay. So can I connect now at the moment? Can I connect what you call three computers inside one port directly? Is it possible? I have one receiver here. Okay. RJ45 port might look, I can show you. This is how an RJ45 port might look like. Okay. So imagine I have one port like this. Now, can I connect three devices to this port? Three different devices to this port? No, because I have only one port here, only one device I can connect to, right? So if I want to connect multiple device, that is where you have to use this thing called switch or hub. So what we do is, why isn't it working? So we have this device called switch, or else we have another device called hub. So what you can do is you can connect this Wi-Fi router to that switch, or Wi-Fi router to that hub, and you can connect all these devices basically to that switch or hub, because switch or hub will have multiple ports. If you look at a switch, or if you look at a hub, visually both will look the same. Where Yeah, this is how a switch might look like. Wait. So visually, switch and hub will look the same, right? Visually, the switch and hub will look the same. But the idea is that you can connect multiple devices here, and you can connect the receiver to the another part. The main difference between switch and hub is in switch you can control. Now, for example, let's say I'm connecting this to Wi-Fi network, then I can control. Okay, let's say I'm connecting four devices here. Let's say I'm connecting one, two, three, four devices. I can tell for which devices to give internet connection and which devices to block. I can control the access. I'll be okay. For these three devices connected, give internet connection. For this device, don't give the internet connection even though it's connected. You can control this in a switch. In a hub, you can't control. In a hub, if you have four devices, all four devices will get the access. Got it? That's why the word switch is there. Now, what do you mean by the word switch? Switch, the idea of switch is on off, right? So here you can control the access. Yeah, it's the main difference. Got it? Tuck it me. Okay. In terms of basic logic gates, there are three main logic gates we have. Okay. So based on these three logic gates only, we actually have built the whole circuits. Okay. Tell me what are the three gates we have? Three basic logic gates we have. Perfect. One of the gates we have is something called as an AND gate. Next, we have something called OR gate. And next, we have something called as a NOT gate. So first thing you should know regarding these three gates is obviously their visual representation, how they look like. This is how the AND gate looks like, where in the left side you have to mention the input signals, in the right side you have the output signal. D how the OR gate looks like. Again, in this curve left side you have the input signals, the right side you put the input signal, and the right side you have the output signal. Okay. So for example, what I mean by these signals are basically the data that's coming from a sensor. So I can connect here one sensor or here one sensor, or I can connect two switches as well. Okay. So I'm getting some data from this side and giving out data from that side. That's why I say input and output. So first thing you should know regarding the three gates are how they look like. If I give you something like this, like this, like this, you should be able to identify what is what. That's the first thing. Second thing is you should be able to know something called as a Boolean expression. Now, for example, now here you're having only one circuit. I mean, here these are, I mean, you are having what do you call a circuit with only one diagram each. Okay, I have drawn three different circuits. No, this has only one circuit, one vertical gate, this has only one gate, and this also has only one gate. Okay. But if you look at this circuit, now this whole thing is one circuit, right? This is one input, this is another input, and this is output. In this circuit, in total, how many gates am I using? For me to obtain the answer for C, I had to go through how many gates, basically? Correct. I had to go through one, two, three. I had to go through three different gates. If I go through all three gates only, I can actually find the answer. I'll show how to find the answer in a while. But I go through all three gates. But if you look at here, if A and B are the input here, C is going to be the output. Here, if A and B are going to be the input, C is going to be the output. If A is the input, then I can say C is the output. So if you look at this scenario, in the first gate, only two inputs I had to go through, and only one gate. Second here, only two inputs, one gate. Here, again, only one input, one gate, right? So normally, what do you call when the no, here it's small, no, and here it's big. In a situation where you have to go through multiple gates, if you're going to, and if you have to like, what do you call, if you have to visually, if you're, I mean, if you want to represent it to someone, if you want to explain that whole circuit to someone, okay, or if you want to, what do you call, show that whole circuit to someone, if you're going to draw all these gates, sometimes the amount of space in your paper won't be enough. Okay. So what we can do is, now these are visual representation of a circuit. No, these are all a visual representation of circuit. So they were like, okay, these are visual representation, but without using any visuals, can we represent the same circuit? Okay. Again, this is also a visual representation. So what do you call, they were like, okay, without visually representing the whole circuit, is it possible to represent this whole circuit using this A and B only? It's A, B, C is there, only using A, B, and C. Is it possible to, what do you call, represent, right? So the, what do you call, to solve that problem, to visually, without representing the whole circuit visually, to represent the whole circuit using, let's say, these A and B and C, we came up with this concept of Boolean algebra representation. Boolean algebra, algebraic representation. This is where you represent the whole circuit without any visuals, but only using this A, B, C kind of values, right? So in that case, what we can do is, to represent the first circuit, we have the inputs as A and B. No, so I write A and B here. To represent that between A and B input, I'm going through the not AND gate, I use a dot. So I can say the A and B input is connected to C. So I'll be like, it's equal to C. Okay. Normally we don't write A dot B equals C. Normally we put that output in the left-hand side. So the most, what do you call, prominent way of representing this would be like C is equal to A dot B. But writing the other way around is also correct. Okay, so what's happening here is I'm not using any visuals. Instead, I'm using just the symbols and the letters. So the dot will represent the AND gate. Similar, tell me, if dot is going to represent AND gate, what do you think is the symbol that's going to represent the OR gate? No, we can't use images. We're use only text, like the typing values, right? So in that case, what are we going to use to represent the OR gate? Perfect. We use a plus. So here the what do you call, we can represent the whole circuit using Boolean algebra only as C is equal to A plus B. So plus will represent the OR gate. Okay. And then here we can represent C is equal to A dash. So in this case, what's happening here is, if you should go and show this to someone who knows logic gates, they will be able to read this, and they will be able to, by looking at this, they'll be able to, okay, there is a circuit where only three values are used, A, B, and C. A and B are the input, C is output, because you're saying C is equal. No? Always what is equal is basically output is equal to input is what we mentioned mostly. Okay. So if someone looks at this, they'll be like, okay, C is the output, because output can be only one data. Okay. Output can't have multiple letters. So we know, okay, C is exactly the output, right? So we can say C is equal to A dot B. And we know, okay, there are two inputs, A and B. And then we have dot there. The dot will give the idea that, okay, between A and B, AND gate is used. So we have these different symbols to figure out what the gate is. So a person can look at this and imagine the gate, or he can even redraw the whole circuit. So the purpose of this is to make your work simple. Drawing is technically going to be a bit hard, and you can't do it easily on a computer. Okay. So when you want to represent a circuit on a computer, we mostly deal with algebra, not with visual representations. Clear? Now, for small things, these are fine. But when a circuit becomes bigger and bigger, and what do you call bigger and bigger, bigger and bigger and bigger, it's not going to be easy to just directly tell, okay, C is equal to A dot B. So let me tell you now, in this kind of questions, how do you find out the Boolean algebra? Okay. Now, at the end of the day, in this whole circuit, who is the output? Exactly. If you look at the final one, you can say right side corner, we have C, right? So C is the output. But you can't directly tell what C is equal to just by in one glance. There is a small processing you have to do. So let me tell you how you can do. Always start from the left side and go towards the right. So go from left to right. Okay. Now, if you're going to go from the left to right order, the first gate you have is here. What's the name of this gate? Perfect. This is called the AND gate. Okay. Now, for this AND gate, you can see one of the input is A, and in the bottom also. What is the input coming from the bottom? For the AND gate, what is the input coming from the bottom? Both the inputs are A. So what you do is write both the inputs with a small space. Okay. What you have to do is always when you get a question, look at the gate and see what are the inputs we have and write those inputs with a small space. So A is one input, A is another input. I keep both the inputs with a small space. Now, how you answer this is in between the inputs, you have to mention the symbol. We have the AND gate here. So what is the symbol used to represent AND gate? Dot is used. So in between the inputs, I mention the dot symbol. Yes, Fatima. Next, we have another AND gate here, which I'm going to highlight in green color. Okay. If you look at this AND gate, okay, look at this AND gate and tell me, for this AND gate which we have here, what is the input that's coming from the top? What is the input we're getting from the top? Correct. The input that's coming from the top is A dot A. Fatima, then just try leaving and join the meeting sometime. There might be a network issue. Okay, the input is A dot A. And then what is the input that's coming from the bottom? It's this. Perfect. That is B. So I told you, write the inputs with a small space. That is, you keep your, what you call write the input, then keep a small space and write the next input. So you're going to write all the inputs with a small space. Keep in mind, AND gate and OR gate can have more than two inputs as well. Okay. So I wrote A dot A space and B. Now, this is one input and this is another input. Okay. Does our input have what do you call which of the input? I'll call this as the first input and I'll call this second input. Which input has more than one character used? Character means like letters. Which input has more than one letters used or more than one character used? Perfect. The first input you can see has more than one character used. So keep in mind when an input has more than one character or more than one letter used, then please use the brackets when you're writing those answers. Okay. Only if there's more than one character, use the brackets. Now tell me, does the input call B, does that require a bracket? No, B doesn't require any brackets. So our answer is going to be A dot A, and here the input is B. Now again, we have the AND gate here. For AND gate, one of the input is A dot E, A dot A, other input is B. Now to represent that AND gate is used here. In between these two inputs, this is one input and this is another input. Between these two inputs, what is the symbol I should use to represent it's an AND gate? Perfect. I'm going to use a dot symbol. So the output that's coming from here, it's basically A dot A dot B. Is this clear? Okay. I'll teach all two things now from here. These two things are out of the syllabus. So if you understood these two, now I'm going to teach you two more things. If you understand those two things, keep in your head. If you don't understand those two things, forget. Thing number one. Okay. The first thing is there's something called as you don't have this in O levels. If you do A level ICT, you will be learning this. There's something called as Boolean algebra simplification. I'm not done with this question. Wait. If you're doing ALO license, you'll be learning something called as Boolean algebra simplification. Okay. I'm not going to teach you all the what you call simplifying methods, but I'll tell you all one logical thing you all can notice here. Now, for example, we have A and we have A. We have this thing called A dot A. Based on your knowledge about this logic gates, because I'm not going to teach you the whole logic gates now. No? You all have learned about logic gates already. No, you know the first time you're hearing these words. No, so based on your idea of logic gates, tell me if you take a specific input or specific output or whatever, it can have two possible values, right? What are the two possible values? This A could be this or that, right? So what could A be? Either perfect. A could be either 0 or else A could be 1. Apart from these two values, can A be any other values? No, that's the basic. Now let's say, for example, let's say the value of A was 1. Sorry, if the value of A was 0. Let's start with 0 value. Let's say if A was 0. Now if A is 0, when you say A dot A, okay, when you say A dot A, we are going to, if you look at AND gates logic, okay, if you're wondering how AND gates logic work, AND gate goes and checks, is AND gates, whenever you're going to go and check the output of AND gate, okay, how AND gate works is it will go and check, is all the inputs 1? Is all input 1? This is how AND gate works. It goes and checks, is all the input 1? Now, if A is equal to 0, that means we have AND gate, that is dot is representing AND gate, and the left and right for the dot, that those are talking about the inputs, no? So here, this AND gate has two inputs, and both the inputs are 0. Now, if you ask this question from that circuit, is all the inputs 1? What will be the answer? Yes or no? Is all the inputs 1 here? No. Now, using Booleans values, if you're going to represent yes and no, normally in computer, no, computers only use Boolean values, basically binaries. Using binaries or Boolean values, if you want to represent no, what is the number that we normally use? Do we use 1 to represent no or 0 to represent no? 0. That means as per AND gates logic, if both the inputs are 0, output is going to be what? If both the inputs are 0, output is perfect. If both the inputs are 0, then output is going to be 0. That's how the AND gate works. Okay. Now, let's go for another situation. If A is equal to 1. If A is equal to 1, that means answer is going to be 1 dot 1. No? Now, here we have AND gate, that the dot is represent AND gate. 1 and 1 are the input. Now, here if you go and ask, if you go and check, what will be the output of this? If you go and check the output, if both the inputs are 1 for AND gate, what will be the result? Basically, you go and check, is all the inputs 1? Is all the inputs 1? Yes. How do you represent 1 in Boolean values? 1 is represented as, sorry, yes is represented as 1. So you go and check, is all the inputs 1? Yes. How do you represent yes in Boolean values? Yes is basically 1. Now tell me, if you look at this situation properly, A could either be 0 or 1. If A was 0, output is 0. If A was 1, output is 1. Right? So if you notice this properly, A dot A is actually equal to A. A dot A is actually equal to A. Is actually there when you go to ALO ICT, you'll be learning something called Boolean algebraic laws killer. You'll be learning this as a law in there. It's a thing called idempotent law. I'm not exactly sure of the name, but there's a law for this name as well. Okay, so the idea is that if you notice properly, A dot A is equal to A. You'll be learning this is all ALO stuff. So A dot A is A dot 0 is 0, A dot 1 is A. Here you will be learning certain laws. Okay, these are all I think comes under idempotent law something you have in A-levels. But if one was 1 and another one was 0, wow, what a brain. What a brain. One flow is like, what if this was 1 and this is 0? In the same situation, can the same thing have two different values? Both of them are A, right? At the same time, can both of them have two different values? Is this even possible? Is this even possible? No, because both of them are the values of A. Both of them are A. It's not even possible, man. If it was a bar, then yes. I mean, here both of them are same. I'm saying both of them are same. It's not even possible. It's not even possible. Okay. Because we are talking about the value of A. Okay. That's why you see, I took two different set situations. I told, see, first situation where A is equal to 0, second situation where A is equal to 1. So you replace A. Then how about A dot 0? Is it possible? It's like this, no, A dot 0, how AND gate works, AND gate goes and checks, is all the inputs 1. If any of the input is 0, is there even 1% possibility for the output to be 1? Like if one of the input was 0, is there even a possibility for the output to be 1? Like A can be what? A can be 0 or A can be 1. So it's either 0.0 or 1.0. Both of us are going to give 0. Got it? That's why we say A dot 0 is always 0. Anyways, that's basically advanced stuffs. That's not relevant to you all. So if you understood it, good. Exactly, Aditi. So if you understood it, you can keep in your mind, or else it's extra. You don't have to simplify. They'll never ask you to simplify it. But there is another thing which they will not ask you to simplify, but your simplifying is not a problem. Now, this is the second thing I told I'm going to tell you all. The second out of the syllabus thing which I'm going to tell you all is, you all can say I have used brackets, right? There are certain situations you can remove brackets. Not all the situations. There are certain situations you can remove the brackets. That is, you go and check, is a symbol inside the bracket and the symbol just out, not very far. The next, along with the brackets outside the symbol, no. Are these two symbols the same? If both of these symbols are same, then you can remove brackets. If both of those symbols are not same, then you can't remove the brackets. So now based on that, tell me, in this situation, can I remove the brackets? Yes or no? Yes, I can remove the brackets. The reason I can remove the brackets is the symbol inside the brackets and outside the brackets, both of them are same. So without writing A dot A plus dot B, I can even write this like this. A dot B killer. I can directly write this. That is possible. Is that clear up to there? Okay. Now the next gate. Is it a must to remove the brackets? No, 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 no. I said you can. For example, when it's raining, if I tell you can use umbrella and go. Now, is it a must to use umbrella and go when it's raining? I'm saying it's raining. If you all want, you all can use the umbrella. Now, is it a must to use umbrella and go? No, if you want, use. If you don't want, get wet and go. Who cares? You think I'm going to be bothered if you all get sick? Oh, not even a bit. Okay. The worst part is I'm a sadist actually. I sometimes might be happy. I won't be sad. Anyways, leave that thing aside. But you called that's just if you want, you can do. It's extra stuffs. That's why I said both of them are extra. If you want, use it. If you don't want, don't use it. It's just extra. Anyways, here we have the NOT gate. So what NOT gate will do is it will write the opposite of the input. Okay. So the input for this NOT gate is what? Again, A dot B. So what will NOT gate do is it will take the input and now it will apply the symbol. So now AND gate, OR gate, what it will do is it will apply the symbol in between. No, NOT gate is a bit different. It's a put a Mongol case. Okay, it's not gate. So it will not apply the symbol in between. It will apply the symbol on the head. They say what you call Oluvata Nagila. There's a nice word in Single. I'm not going to tell it. There's like something they say they go to the head and they dance killer. Something like that. So NOT gate is like that. It'll jump to your head and it'll dance. So for the whole input, you'll have a line going on. What if A equals 0 and B also 0? If that AND gate is A dot B, the answer, if A dot A equals B dot B, so can we remove the answer as the same? You can remove the brackets. That is situation. No? When you take A and B, A is representing one value and B is representing another value. That's why we have A and B. No? If not, they could have used for this as A and this also they could have used A. So it's possible. We are talking about probabilities, right? It's there's a probability for both to be zero, fine, but there is also a probability for this to be one. So your situation should be suitable for all the like your solution should be suitable for all the situations. Sorry, correct, Aditi. Okay. Anyways, what do you called? Yeah. So C is basically equal to A dot B. Okay, but based on what I taught you a while ago, you can simplify this and write if you all want this A dot B whole thing dash. Both of them are going to give the same idea. Okay. Shumed, what are you doing here? So both of them give the same idea. If you all want, you all can check and see. I'm not going to show you all, okay? If you all can differentiate and see, you'll get the same idea. Anyways, let's now do the question based on that, right? So you all, if you all know how these three gates work, you're good to go. Okay. So how the AND gate works is AND gate goes and checks this. It'll go and check is all the inputs one. Okay. Just like that, tell me, what do you think the OR gate will go and check? It'll go and check what is the input. Like how does it go? What does it go and check in the input? Is what one? Perfect. It will go and check is any of the inputs or is either one of the inputs one. Okay, it will go and check is any input one. Not all input, but here it will go and check any input. මොකක් හරි එකක්වත් එක one නැද්ද කියලා it will go and check. Is any input one? This is how the OR gate works. So it's like a question. When you say is, if I come and ask you, is it raining? What do you call? Are you? What do you call? Is it sunny? Or if I ask you, is it what do you call morning? Is it evening? I mean, or is it morning? Those kind of questions are like yes or no questions normally. So in those yes or no questions, most of these is kind of questions will always have two answers, which is yes or else no. Yes, Zainam, yes. Okay. Rainy or sunny? Not rainy or sunny. Like if I ask, is it rainy? Then it's a yes or no question. Okay. So if I ask what you called in yes or no questions, always yes is represented using one in Boolean values, and no is represented using zero. So what do you call the output C will become one if all the inputs are one. In an OR gate, the output C will be one if any of the input is one. That's how it actually works. Anyways, when you say not gate, how not gate works is it will give you the opposite of the input. This is how the three gates work. If you all just by heart these three, you're good to go on how to deal with AND gate, OR gate, and NOT gate. All, any, opposite. Apart from these three basic logic gates, there is something called combination logic gates as well. Do you have breakfast with juice or paste? No, that's basically you're having a choice. No, here it's not a choice. It's just a yes or no question. Okay, so next is basically something called as a combination logic gates. Here we have one gate called NAND gate. So NAND gate and NOR gate. We have something called NAND gate. We have something called NOR gate. The NAND gate will look like the AND gate with a small circle in front. NOR gate will look like a OR gate with a small circle in front. In terms of how they work, if A and B are the inputs, for NAND gate, it's basically A dot B and gates opposite. So A dot B dash. NOR gate is OR gates opposite. So A plus B dash. Okay. So if you're asking how they work, this fellow gives the opposite of AND gate, and OR gate gives you the so NOR gate gives you the opposite of OR gate. So in logic gates, these are the main things which you should know. As long as you AND or and not, if you know those three people, how it works, these three are gonna be easy. What does opposite of the input mean? What I mean by opposite of input is if A is 1, for example, if you look at this equation here, A is input now. Okay. If A is 1, then C is opposite of A. So if A is 1, that means C is equal to how much? If A is 1, I say seeing opposite output is equal to opposite of A. So if A is 1, that means C will be 0. Similarly, if A is 0, what do you think C will be? Like opposite of the input. That's what. Opposite of, if A is 0, then C is going to be equal to 1. Opposite of the input. Got it? Okay, next. Let's come back to this logic gate question. So here they're asking us to complete the truth table. Okay, so truth table is basically what you do is you go and check those logics. How you fill these values is you go and check those logics and see how to find the answer. Okay, so first thing we have the value for here. Okay, so we found out already the value of C can be found by saying okay, see that C is equal to A dot B because that's the output. No, so you see the value of C is basically we found out here that it's A dot B whole thing dash. Okay, so first of all, let's see what is A dot B's value, and then let's see what is the value of A dot B whole thing dash. Okay. Yes, Abdullah. I think fourth time I'm answering that question. Now, if the value of A was 0 and if the value of B was 0, let's go one by one. Okay. We have A dot B whole thing dash, right? When you say A dot B whole thing dash, it gives you the idea of, first of all, let's take A dot B, and then let's take the idea of opposite of A dot B. Okay, that'll make the work easy. First of all, let's check A dot B, and then let's check what do you call the value of the opposite. Now, if A was 0 and B also was 0, that's the first situation, both of them are 0. If both of them are 0, and if both of them go through the AND gate, dot means AND gate, no? If both of them go through the AND gate, what will be the result? I told you how AND gate works, right? AND gate goes and checks, is all the input 1? Exactly. The result of A dot A is going to be 0. You go and check, is all the inputs 1? No. So you represent no as 0. Now we have to find out what is the opposite of no, because dash is representing the word opposite. So what is the opposite of 0? Exactly. That is equal to 1. So in the first situation, the value of C is going to be equal to 1. Some of you must have understood, some of you must have not understood. So again, look at how I'm doing the second question. Okay. So how I'm finding the value of C is I'm finding the value of C. What do you call? Akhil, I told you recording is available now. So the recording is not on or on. That's not your problem now. I have multiple ways of recording it. I answer the question, recording is available. Simple. So focus here. So come back to the point. Okay. So what do you call? To know the answer, you need to know. Yeah, I'll be sharing the notes as well. That's out of the syllabus mode. I told you that was what I was explaining the whole thing here. The whole thing's explanation was that. I'm not going, I told you I will not explain that, but at least at that time you could have asked that question, not now. Anyways, so we know you can find the value of C using the equation C is equal to A dot B whole thing dash. So now we're going to apply this for the second row as well. Okay. In the second row we have, okay, the second row we have the value of A as 0 and the value of B as 1. So we have to figure out what is the answer of 0 dot 1 whole thing dash. Okay. First of all, tell me if 0 and 1 are the input for the AND gate. No, dot is representing AND gate. No, if 0 and 1 are the input for the AND gate, what will be the output of the AND gate? What is the answer of 0 dot 1? Correct. That's why I said both of them are same. See, I told you both of them are same. That's why I simplify now. Nothing if this if they give two different answers, can I even work on this yellow color highlighted version? No. I told you both of them will give the same answer. I'm not going to prove it. Okay, 0 dot 0, that's going to give you 0. Okay, because AND gate goes and checks all the inputs 0. Answer is no. So now we have to figure out what's the opposite of Samuel. That's not the end syllabus. Okay, so then you have what do you call the NOT gate for 0. So opposite of 0 is what? Only if the same we can remove the brackets, right? The respective same. That means just before the brackets and just after the brackets if it's same. Actually, both the sides has to be same. Right side, left side, both sides. It's better if you don't remove the brackets. That's because that's the removing bracket is not there in the syllabus. I told that's extra. It's a risk. Anyways, opposite of 0 is 1. Correct. So in that case, you can go and write here also as 1. Now let's apply the same thing for the next one. Again, same equation we are going to follow. C equals A dot B whole thing dash. In the third row, the value of A is 1. The value of B is 0. So you can see a value of A was 1, value of B was 0. Okay. So we have to find 1 dot 0 whole thing dash. So what is the value of 1 dot 0? Correct. 1 dot 0 is going to give you 0. So now opposite of 0, not gate means opposite. No, opposite of 0. That's going to be 1. So our answer is going to be 1 here. Now next question. C equals A dot B whole thing dash. A is 1, B is 1, 1 dot 1 whole thing dash. First of all, what is 1 dot 1 equal to? 1 dot 1 is equal to 1. Now 1 dash means opposite of 1. What is opposite of 1? That's equal to 0. So in this question, the truth table would look something like this. Is that clear all of you? So this is how you do this question. If you have any questions, drop in the chat. Next. Fill in the blanks using your knowledge of color coding system which is used to represent a color by the computer. Okay, this is basically number conversion. Grade 10 lesson number 3. Yes, Mahadi. I have repeated this for the 5th or 6th time. You can get it after this in the channel. Okay. So normally if you take hexagonal color codes, if you're taking color codes in the computers, you can represent in two ways. Okay. One is called the hexadecimal color code representation. Other one is called the RGB color code. I can use this space, or I'll just go for a new page. Okay. Normally represent the mirror in two main ways. If I'm writing now, I'll be sharing it to you after the class. So you all just, if I later you don't have to take screenshots. Okay, so one is RGB color code and one is the hexadecimal color codes. So for example, if you get a question like this, when T blah 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 blah, first thing to keep answer. When you take the hexadecimal color code, it would look something like this. Here we have something called hashtag 633A, right? Hashtag 633A, right? Normally, a hexadecimal color code will have 6 characters. Okay, there'll be 6 different values. So if you notice here, yes, Oshadi. If you notice here, we have only 4, right? We have only 4 letters. So balance how many more letters, how many more characters are missing here in this color code? Characters here. If it's a complete color code, it should have another how many more? Yes, Rekaz. Correct. There has to be 2 more characters which we write in a hex color code. The first 2 digit will represent the amount of red that is being used. The middle 2 will represent the amount of used RGB, and the last 2 digit will represent the amount of blue used. Okay, so I'm stuck here. I don't think so. But recall the first 2 digit will represent the amount of red used, middle 2 will represent the amount of green used, and the last 2 will represent the amount of. Why am I lagging? Give me a moment. How about now? Mic testing 1, 2, 3. How about now? Okay, no, all good. So yeah, if you take color codes in HTML, sorry, in website, in you can. Okay, let me off another view. Yeah, okay. HTML we can classify this categories, right? One is our hexadecimal color code. I don't think it's still as well because my phone is proper. I'm just calculating for the phone only. Yeah, it is proper. Yes, Fahama. That you think Starlink is very cheap? It is. How is my voice now? Voice is okay, right? Any issues in the voice? Is there any issue in the voice? You still having issue? That's right, yeah. Now okay. Is video having an issue? I'm moving my head. Give me a moment. I'll quickly change my IP address and come. The moment. How about now? Is it lagging still? No. Perfect. Yeah, I was not moving, so it. Okay. So if you take what you call colors in your computers, you can represent colors in only two main ways. One is using RGB color codes, other one is using hexadecimal color codes. RGB color code is where, see, in hexadecimal color code, if you take, we have six different characters. Okay. Out of those six characters, the first two is representing the amount of red used, the middle two is representing the amount of green used, and the last two is representing the amount of blue used. Okay. So now what we have to do is we have to figure out in this question, we have to figure out the amount of blue, right? There is a connection between RGB and hexa as well. You can find Okay, hexadecimal values, decimal to hexadecimal values. Okay. Now here the R is 99 something and 227. Okay, if you take RGB values, they said 99 something and 227. So first of all, I'll show you all how you can find out that these two values, To do that, you have to convert number 227 from decimal to hexadecimal. Okay. To convert number 227 to hexadecimal, if you're always having this confusion of how to convert to binary, octal, or whatever from decimal, always easiest is think how will you do for the binary, because you obviously all of you all might never forget binary, because from grade 9 in maths even you'll have learned that, right? To convert to binary, or divide by 2. The same process but different value. To convert to binary, if you divide by 2, a decimal number, to convert binary, if you're going to divide by 2, to convert hexadecimal, you divide by how much? Perfect. Divide by 16. So if you divide this by 16, 16 and 1 is 16, 4, 5, 6, 6 remains. Times 5 is 80, 4 is 32, 64, and 16 times 4 is 64. So 64, 65, 66, 67. 3 remains. 16 times 1 is 16. 160, 6, 12, 16, 32, 64, 160, 224. Yeah, okay. I'll do calculations using my head, so it might look a bit weird, but yeah. So divide by 16. 16 times 0 is 0. And then 14 remains. Normally in hexadecimal, what do you call? You represent the numbers more than 9, which is number 10, 11, 12, 13, 14. Okay. You represent it. What do you call? What do you mean 16? Yeah. Okay. So what do you call when you take hexadecimal numbers above 9, you represent them using letters, right? So A is used to represent 10, B is used to represent 11. So likewise, tell me, what is the letter used to represent 14? So these are letters we use in hexadecimal to represent values, huh? Perfect. That's basically E. So always we write the answer from bottom to top. So 227 hexadecimal is equal to E3, sorry. E3 base 16. Sorry, 15. What do you call E3 base 16, right? So in that case, value that's going to come here is E3. So to find RGB to hexadecimal, just keep it in mind, you have to convert from decimal to hexa. Now using this idea, tell me, we have to find out here the value of G, right? In the question you can see, we have to find out the value of G here. If RGB to hexa is to convert from decimal to hexa, that means how can you find out hexa to RGB? What you should do? What do you think you have to do? In case we are unsure of the division by 16, can we convert decimal to binary and then binary? Yeah, yes, we can do it. That's easy. Correct. To do that, it will be like hexa to decimal. Just the opposite. Okay. So we're going to convert from decimal, hexadecimal, decimal. This is the shortest method we have. Binary, we have another method. Okay. What do you call to convert from hexa to decimal? What we should do is we have what is the hexa value we have here? We have 3a. Again, if you are confused how to convert something to decimal, then you always again imagine, okay, if it was binary, how I will do? I'll multiply by binary's place value. So if it's hexa, I will multiply by hexa's place value, which is I will multiply each digit by hexa, because now 3a is a hexadecimal number now. So we're going to multiply by hexadecimal numbers place value. It is 16 to the power 0 is 1, 16 to the power 1 is 16. When you multiply 1 and a is equal to the value of 10. So 1 times 10 is going to be equal to 10. And then if you multiply 16 by 3, That's going to be equal to 32, 38, 48. So answer is going to be 48 plus 10, which is 58. So here the amount in green is going to be equal to 58. Is that clear, all of you? Any questions? Is anything to convert decimal? We should multiply anything to convert from decimal to something we should divide. Eh? Anything to convert decimal you should multiply, anything to convert from decimal. It's not like that. If you're going to convert from decimal to something, we divide by that something's place value. If you're going to convert from something to decimal, you multiply each digit by the respective, what do you call, base numbers base, so respect numbers place value. So to get that place value, I need that base and all those stuffs. But yeah, to decimal to something divide, something to decimal multiply. I'm unaware that there's a concept like this. Is there in your grade 10 lesson number 3? Hexadecimal, you look unwanted. Okay, anyways, coming back to the point. So in terms of remembering here, the only thing you remember basically is this part. In numbers, in questions, you can get something called hexadecimal RGB color code questions like this. To convert between this, the only takeaway in your brain that has to be there is this part. To convert from RGB to hexa, you divide, you convert from decimal to hexadecimal. To convert from hexadecimal color code to RGB color code, you convert the hexadecimal value to decimal. Okay, these are the two main things. Apart from these two things, the other main thing you have to keep in mind is in a hexadecimal color code, the first two digits are representing the value of R. The last two digits are representing the value of blue. The middle two digits are representing the value of green. Just this much. So Ajay, that's that. It's there in the syllabus. I've always had a confusion converting. I cannot remember the decimal to something divide. Easy. If you are wondering how I keep this in mind, I always think in the part of binary because binary is what we do since grade 9, right? So imagine, okay, from decimal to binary, how I will do? Divide by 2. So you here like decimal to binary divide by 2, decimal to hexa divide by 16. And same thing you do for here as well. Hexa. Actually, you all, I think you all learn number conversion when, I mean, it's what do you call unit conversions? I think grade 9 is the first time you all learned about unit conversions, right? Actually, we used to learn in our school from grade 6. So comparatively, I remember it more, that's why. Anyways, yeah. Eighth. I was here from grade 6 actually. The master WhatsApp has all the number conversions. If there any of you who are weak in number conversions, just check there. That's something called as coding. These ones. Not number system, that's called coding systems. I'll come to that later on if we get a question. Sometimes we can't remember what we ate last night. How can we remember what we ate in this? But I still can remember what I learned in grade 2, man. Grade 1. I even still can remember the first time I learned reading the clock in grade 2. This is when we learned how to read clock. Grade 1, first day. Not grade 1, first day, that small classroom. Yeah, grade 1, first day. Our class teacher was teaching us about the multiplication table. I can even remember her name, Miss Hinaya. She was teaching the multiplication table, not English class or maths class. So she didn't do the multiplication table, but she was a class teacher. Anyways, not exactly. Yes, Fahama. Anyways, sorry, Fahama. Now focus here. I'll go for the next question. You might get the hang of it. Huh? So if those who did not understand how I got for the blue, Focus on the light green, huh? Yes, Vayar, Vayar. Okay, next. Light green. Now, in this question, they have given us the R value, G value. We are going to find the blue value. Okay. To find the blue value, what is the data we need? Okay, let's go step by step. Focus here. To find the value of blue, what is the data we need? What is the input? Let I focus here, man. To find the value of blue, what is the data you need? The hex value of blue. Okay, what is the hex value of blue here? What is the hex value of blue here? Correct. You can see the first two digits and last two digits are given. So here the first two is red, the last two is middle two is green, the last two digits is blue, right? So now we know the value in hexadecimal is 19. Okay. So using that 19 only, we're going to find the blue. Okay. From hexa, now you know already this value is in hexa, right? So we have to figure out the value here. All the RGB values are there in, keep in mind, all the RGB values are there in the decimal form, right? So you have to convert from hexa to something else. That something is anyways definitely decimal, right? So what we're going to do is to convert from hexa to decimal. Anything to decimal, you multiply each of those digits by its place value. That is 1 and 9, 16 to the power 0, 16 to the power 1, 1, 16. 1 times 9 is 9, 16 times 1 is 16, 16 plus 9 is 25. So here the answer is going to be 25. This is how you find the answer. Now, similarly, tell me to find the value of that green out of the data we have, which data should we use? Should we use a data called 15, 234, or 0f, or 19? Which data has to be used to find the value of green? Correct, 234. So there what we're going to do is we're going to convert from decimal to hexadecimal. Okay, decimal to hexa, right? So decimal number is 234. To convert to hexa, you divide by 16. Focus on the class. I don't like your replying others' messages unwantedly. If you really want to reply, it should be meaningful. You don't have to give your emotions and all in the chat. Okay, you can keep your emotions for yourself. I mean, opinions to yourself. 16 times 1 is 16. Is 4, 7 remains 74. So 4 is 64, 10 remains. By 16, 16 times 0 is 0, 14 remains. In hexadecimal, what is the letter we give for 14? Hmm. Correct. That's E. And what is the letter we give for the letter number 10? So we read the answer from bottom to top. So answer is going to be equal to EA base 16. So this is going to be EA. Is that clear, all of you? Yes or no? Which part? So the only thing you have to keep in mind, again, I'm telling you is one thing. Okay, again, how you got 25? Here, if you're weak at the conversions, then this here in this question I'm not teaching you how to convert numbers. That's not the main part of like how do you convert from hexadecimal. This is not this is not what I'm teaching. Or teach you how to convert from decimal to hexa. This is not what I'm teaching here. If you are weak at those two, if you don't understand this part or this part, then my solution for all of you is just go to YouTube, search for Master YouTube channel, and in that YouTube channel you'll be getting the what do you call there's a recording called number conversions. So if you're weak at number conversions, then you have to go and watch this number conversion recording. Okay, because this has in detail. You can see for 2.5 hours I'm teaching number conversions, which is in depth. Whatever I'll be giving you notes as well. So if you're having issues in this portion, then that's what to see. Apart from that, if you are wondering how I got 25, again listen how I'm telling you. Okay. So how you find is rule number one you have to keep in mind is in hexadecimal color code, there are a total of how many digits or how many characters? Correct. In hexadecimal digit number, there are 2, 3, 4, 5, 6, and a hashtag in front. Out of these 6 characters, the first 2 characters are representing the amount of which color being used? Perfect. The amount of red being used. The middle 2 colors are representing the amount of what color being used? Perfect. The amount of green being used. And the last 2 digits are talking the amount of which color being used? Perfect. The amount of blue used. So if you want to find out, okay, what is the value for R, what is the value for G, and what is the value for B, what you should do is you have to convert respectively. Meaning, if you know the RGB value, then you can convert to hexa. And how do you convert hexa? You convert the decimal to hexadecimal. Now, for example, in this question, they have already given us as data that 99 is the value for R and 227 is the value for blue. So if you want to find out the hexadecimal for R, okay, if you want to find out what are what are the two values that will come for here, then what you do is that R value you convert to hexa. How do you convert hexa? You divide each by 16. This is a whole process to do. Okay, like for example, if I take the 99, I'll show you all. If I divide 99 by 16, 16 times 5 is 80. So 16 times 6 is 96. 97, 98, 99. 3 remains. Divide by 16. 16 times 0 is 0. 6 remains. From bottom to top, answer is 63. So you can see the question they gave you 63 in the front here, right? If you're wondering how did they get that 63, this is how they got the 63. Okay, if you know 99 as a data, you need either one of them as data. Okay, if you don't have both, you can't figure it out. Either you should know the R value or else you should know the H value. I mean, you should know the RGB value or else hexadecimal. You should know either one of them. So convert from RGB to hexa, you convert from decimal to hexa. To convert from hexa to RGB is basically hexadecimal. That's the point. First 2 digits are representing red, middle 2 is green, last 2 is blue. So how I found 25 is blue is basically, if you look at the question they have given here, in that question you can see they have given what you call the hexadecimal value is 0f blank 19. Okay. Now here I have two values. Here I have two values. Now I know the middle there is a blank, right? Middle there is going to be 2 digits, and these 2 digits are going to represent the amount of green used. Okay, I'll figure out that later. But to find out the amount of blue used, you can see I already know the last 2 digits represent blue. So I should be like, okay, 19 is in hexadecimal. What is the value of 19 in RGB? So to convert from hexa to RGB, that is this. I have to convert from what? Hexadecimal. So hexa value is 19 means to convert that to decimal, I multiply each digit by its place value. And that's going to give me 16 plus 9, which is 25. This is number conversion. This is not connected to that, what you call, what I'm explaining at the moment. I'm talking about color conversions. But to do color conversion, you need to know number conversions. If you're weak at that part, then this is a solution for you because this will take, you can see how long I have taken just for 9 conversions. Is this the only type of question that can come from this part? Yeah, RGB to hexa, hexa to RGB. Other than that, they can give MCQs basically. What's the purpose of using color codes? Representing colors in computers. So for example, if you take like this situation, you have the YouTube logo here, right? Is there a picture? Or let's say you have a line around this YouTube channel, right? I can go and change it using RGB and hexadecimal color codes. For example, there is a red color border, right? I can use from red color, I can change it to, let's say here. Now it's in around pinkish color, right? That's because if you look at the downside down here, can you see they put hash one killer. Look at the bottom inside, you can see here. Not here, like in the right side bottom. This is hexadecimal color codes. So in any this one you deal, any website you deal with, we represent colors in hexadecimal. So this is hexadecimal. Clear? Yes, regards. Next. Match column A with column B. So this is regarding operating system. Linux, Windows, ATM, DOS. Windows is one of the one that's very common to all of you, all right? So tell me, Windows comes under which operating system? A, B, C, or D? I'm scared I'm a teacher. I should know it. How will they ask in MCQ? They can ask what is the smallest value of R, what is the largest value of R. I mean, the RGB value smallest is 0. The largest is 255. So that can be asked. Hexadecimal, the smallest is 0. The largest is F. So, or they can ask how can hexadecimal value starts with symbol when it's hashed. So apart from hashtag, you can also start with and actually and H, I guess. Oh, and I think and and H or and I'm not sure exactly, but yeah, you can get those kind of questions. Just go through the textbook, you'll get those. Not very rare, very, very rare. I'm just saying if they really want to ask. Anyways, coming back to the main point. Windows 8.1, that's a what type of operating system? A, B, C, or D? If you look at this situation here, Windows operating system is a multi-user multitasking operating system. To be more precise, it's a multi-user multitasking operating system. But out of the given answers, we can use Windows here. Ah, no, no, sorry, not multi-user multitasking. Windows is a single-user multitasking operating system. To be more precise, it's a single-user multitasking. But for now, let's use like this. To be more precise, this is a single-user multitasking operating system. If you take Linux, Linux is actually have several versions. One of the main versions of Linux is multi-user multitasking. You have single task as well, but you can do multitasking as well. So the most suitable answer for this is going to be Linux. Out of ATM and DOS, DOS is also owned by Microsoft only. It's one of the old operating system. Microsoft DOS is a single-use operating system, so better connect this and this. ATM is a real-time operating system. Apart from ATM, even these certain calculators has real-time operating system, and even certain drones have real-time operating systems. If you match them correctly, this is how you get them, right? So there's four types of actually there are, even though these are four main categories, there are subcategories as well. Like I told you, Windows is basically a single-user multitasking. It comes under both categories to be precise. But if you're asking like mainly what is more suitable, then single use is where DOS comes, and Linux is where multi-user comes, Windows is where multitask, and ATM comes under the category of real time. Any questions anyone have here? There's nothing big here. It's regarding operating systems type. Drone. The giving out, yeah, real time operating system is the output you will be getting ASAP, like within, without like, as soon as you press the input, you get the output. That kind of scenario. Real time operating system is where, but you after you give the input, once you give the input, the next moment you get the output. That's what real time operating system is. Actually, ATM machine is not a real time operating system. Not all the ATMs are real time. It's DOS, GUI, or CLI. To be honest, I don't know. I think it's GUI. As I can remember, it's GUI. I'm not sure, but double check. So computer also give it at the same time. No, you have a loading time. No. For example, if I go, it depends on you. If it even 1 second is a loading time, I'm saying less than a second. That's why I'm saying not all the ATM machine comes on a real time operating system. But normally, if you take majority of the ATM machines you all come across in Sri Lanka, they have Windows running. If you can, there sometime you might notice you can connect. There's a way you can connect one type of keyboard there. If you connect that type of keyboard and press the escape key, you'll get the Windows operating system. So around 90% of the operating systems in ATM machines in Sri Lanka actually has Windows running if you go back. So that's why it takes time to give you results. What's the type of keyboard? That is the type of keyboard you can connect to cars as well. Even for vehicles, you can connect those keyboard. I can't remember the name of that keyboard, but there's a device you can connect to vehicles as well and control the vehicle. So you can use that. I got it's there's a port for that. I can't remember the name of it, but yeah. Any vehicle you can. Every 90% of 99% of the vehicles you have that, as I know. In commercial bank, I don't think you can easily do it. But if you go for Nation Trust Bank, it's very easy. In Nation Trust Bank, if you press the cancel key or escape key, or I think it's touch screen. You try to select front, up or down, or like from the corners, pull or something. In Nation Trust Bank, you can easily get it. They're not blocked some. As early it was possible, but still it's there. Yeah, obviously. Yeah, Hannah, you can. Okay, next. Kind of. The above diagram shows icons of view types in presentation software. Name W, X, Y. Okay. What does W represent? Which type of view? Is it normal, slideshow, reading? Is it regarding presentations? Huh? Representing presentation. How do you call this W view as? Perfect. This is called the normal view, right? Now here you can see multiple slides are there and you can rearrange the slides. So this view that is there to rearrange the slides. What do you call this view as? Sorry. Perfect. You call this view as a slide sorter view. And you can see there's one view like a book. This like looks like a book, right? So what do you do with book? What do you think this book is going to be? Out of these answers, what is reflecting the idea of like book? What do you do a book? You read a book, right? So it's like the reading view. And the last one you can see, it's like you're presenting it. So that's called the slideshow view. So this is regarding the presentation lesson. Next. Among the following facilities of a word processing software, write down only the facilities that can be used in a page setup. Okay. So in Word, if you look at the top itself, there are like multiple tabs like home, and then you have to edit. Then you have something called page setup, mailing, killer, there are help, killer multiple tabs. So they are saying what are the relevant for page setup. So regarding setting up a page, word count is not something relevant to the page. Orientation, it is relevant to the page. Normally there are two orientation. One is like this and one is like this. How do you call this orientation as? If the page is like this, how do you call this orientation as? Perfect. That's the portrait orientation. And how do you call this orientation as? Correct. This is called the landscape orientation. Page numbers. This is not set up using the page. This is not set in the page. Sorry, in the page setup place, but you can set up in the page as well. Page size. This is yes. Margins. Yes. Page numbers. I'm not sure whether you can do it. Let's see. Like, what I Jolo just joblessly seeing my laptop and waiting you. I mean, the subscriptions I have. Exactly. No, you can use it for all only if you all have the student email address. If your school has given you a student email address, you can use it for free. Anyways, in the layout page, you can't set the page numbers. Correct. You can set the page numbers in the insert page has a page numbers actually, or else the view also has page numbers. Even though in mine it's not showing, in header and footer you can get it, but normally in view also you can get the page numbers. So that's not something in page numbers. Correct. So yeah, like I said earlier, it's basically orientation, page size, and margin. These are three things you can find in this page setup. That's here you have layout killer, but these are something relevant to page setup. See under page setup you have here. Okay, regarding page setup you have here. Use red. Regarding page setup we have the margins, orientation, size, columns, breaks, and line numbers. Focus here. Keep your chats aside. I already told you all you can get those for free if you have a university ID, which you all don't have. Basically, if you have an email address ending with your school's name. Sorry, next. Following table shows relative and absolute cell reference used in spreadsheet software. Match the number in column A with the label in column B and writing pairs. So in spreadsheet, basically, when you're writing formulas, inside of then you can get the subscription. Okay. When writing formulas, inside of formula, if you're going to mention a cell address, for example, if you're going to mention something like this equals A1 plus 25, okay, in a formula, you can see in this formula have you cell address no. So mentioning a cell address in a formula, we call this as cell referencing, right? We know cell referencing. If you use the dollar symbol, then that type of cell referencing we call as absolute cell referencing. If there is no what do you call dollar symbol, then that's relative cell referencing. Exactly. Okay. So in this situation we have here, sorry, in this situation we have here, out of A, B, C, and D, tell me what are the answers that's representing relative cell referencing? I said if the dollar symbol is there is absolute, without dollar symbol is relative, right? So what is relative cell referencing in the answers given there? Correct. A is talking about relative cell referencing. So that's going to be matched with this. Now B, C, D, all three are absolute. But when you take absolute cell referencing, we add in the dollar symbol. Fine. Okay. Depending on where the dollar symbol is added, you can call it. You can differentiate into three categories. Okay. Normally, if the dollar symbol is like a protection we write for the cell address. I'll tell you why do we do that when we come for the spreadsheet question next. But if you take this dollar symbol, the point is regarding if you have this dollar symbol, it will this one. It will act like a protection barrier. Okay. So the dollar symbol is there in front of the column name, right? For example, A is if you take A1 cell address, if it's there in front of the column name, then we say okay, it's like it is like acting like a bodyguard for A, and it's protecting the A from not getting changed. What do you mean by change all those stuff? I'll tell later. But basically, keep in mind, this dollar symbol is now protecting A. If the dollar symbol is there for the number, in front of the number, then we can be, okay, it's protecting the number. If the dollar symbol is there in front of both, then we can say it's protecting both. Okay. So this we call as column absolute, this we call row absolute, this we call column and row absolute. So here column absolute, it's protecting the column name. So which one is protecting the column name? B, C, or D? Correct. B is protecting the column name. Then what is protecting the row number? Row absolute. Perfect. That is C. And what is talking about column and row absolute? Perfect. That is D. So if you match them correctly, this is what they're representing. So if you're wondering what did I tell about this column change, row changing? Okay. What were you there in yesterday's class? Go and watch the recording there. The grade 10 fellow answered this question, I would have answered. I taught the whole spreadsheet lesson in yesterday's class. Everything from scratch. If there's anyone of you who are weak at spreadsheet, I have a solution for you all. What do you called? I'll be discussing a spreadsheet question as well. But if you're weak at spreadsheets theory, you all have not covered the theoretical part of spreadsheet, then wait, it's there by the browser. I'll give you all yesterday's online class recording because yesterday's online class for grade 11 we had a recap class. This I'm giving only for you all basically. Technically, you have to pay and get these stuffs. I'm giving you all for free. Use it wisely. Only for the people who came for this seminar. Copy. Yeah. I have shared the link in a chat. This is where I taught the whole spreadsheet lesson from scratch. Okay. No. Then why will I teach more? But you call the whole spreadsheet lesson from scratch is there in the recording. So if you're a week in spreadsheets theory, check there. But only knowing the theory, you can't get marks. Obviously, you have to practice questions. So we are doing a what do you call spreadsheet questions. Wait, there is no password for that. Next, write to difference between a manual database and computerized database actually. Okay, just click on the link, it'll open in a browser. Just click on that link, it'll open in the browser. And after it goes to the browser, you can just keep it in the background, right? Anyways, so if you take this what you call database are used normally to store data, right? Database, if you take, it's used to store data. Used to store data. So when you're storing data, you can store it on in what you call in a what you call place without any computers used, or you can store it in a place where you're using the computer to store the data, right? So without the computer, if you're going to store the data, that's basically manual database. With the help of the computer, if you're going to store the data, we call this a computerized or computer-based database. Okay, if you're using the computer, it's computer-based. So for example, in your school, you'll have this one, right? In the classroom, you'll have this attendance you'll mark in that register, right? If you take your register, is that register or a database? In your school, you'll have this register, right? Where you'll go and have your students' details, your name, your contact number, your address, all those details are there, right? Is that a database? Yes, because that is a place where your data is stored. But is that a manual database or computer-based database or computerized database? Which category does it come under? Perfect. Your school register that comes under manual because that's completely without any computer being used. Okay. But for example, if you take something like this, let's say, if you go and register for a website, even computer based also needs manpower. The difference is you're having a computer in the process. Now, for example, let's say I'm going to store the students' details on my computer. Let's say I open a spreadsheet. Okay. For example, let's say I have an Excel sheet here. And I'm going to write that I'm going to store your details here. I'm going to have here your name, your address. Okay, sorry, name, and let's say your address and your contact number, all those stuff. So let's say I'm going to store in this spreadsheet, the spreadsheet. Okay, let's say I'm going to store it here. Now, if I'm going to store all of your details here, will this be a manual database or will this be a computerized database? I mean, a computer-based database? Perfect. That will be a computer-based database. So the main difference between manual and computer-based is in manual, there is no computers involved. In computer-based, there is a computer involved in some sort of a process. Some way or the other, it's there. Okay. So the main difference between them, in terms of differences, if you're going to take like between manual and computer-based, the differences you all can mention. Manual database and computer-based. Some of the key differences you all can see is the main difference you all can see is obviously the use of the computer. But by using the computer, one of the main advantage you can get is in computer-based database, there is a it's easy to retrieve data. What I mean by retrieve data is, for example, do you all know something called as this phone book? Phone book can make a what do you call rainbow pages killer? Rainbow pages. Do you all know this? Have you all heard about this book called Rainbow Pages? There is a book. So back then, This is like a you all know Truecaller, right? Do you all know what is Truecaller? This was our true call earlier. Okay, when it is, oh, back then this is basically where we go and search for not our true caller plus our Google basically. So if you want to know someone's contact number, for example, let's say you want a shop's contact number, you go to Google, you type the name of that shop, you get the contact number, right? But back then when we wanted to find contact numbers, all those stuffs, uh, no, it's very different. But you call when you want to find contact numbers, we had this something called rainbow pages. So this has every shop or every place, everyone's name is there and their contact number is there. Or if I have watched movies, there is a movie called The Robo, or else in Tamil it goes Endiran. If you have noticed, there's one scene where he scans what do you call a book. In a saloon, he scans a book, and then the question, the other fellow will ask a question, okay, what is my address? What is my contact number? What is my name, Kela? Okay. So that's basically he was scanning these rainbow pages. It's a contact number. Okay, or everyone's name, contact, address is there in this. So back then, so like this now, if you take this is also database. Now this is a manual database, right? Now if I'm asking you to find someone's contact number or find someone's name or something or find someone's address, the time taken for it, is it going to be a less amount of time taken or more amount of time taken if you're going to find in this book? Less time or more time? Exactly. You're going to spend a lot of time going through each and every page sometimes, or at least a couple of pages you're going to go through to find the contact number. So that's going to take time for you. Okay. But the same thing, if I had all of your details in Excel sheet like this, what I can do, I can go and type here. You have the find option, right? Find and replace. So I can go and type the name here. Let's say, for example, I write Amal here. I'll find out exactly what is Amal's contact number. Okay, or Bimal. So for example, a computerized database has a search bar. But can you find the search bar in the manual database? Exactly, like finding a word in Google and dictionary. Correct. So retrieving means obtaining. In a computer-based database, you can obtain the data easily, but in a manual database, it's hard or it takes time to retrieve data. Is that clear of you? It is in alphabetic order, correct? Next, in terms of storage space, okay, I'm not talking about the MB, GB, those storage space. I'm talking about physical storage, which means in our environment, how much of space I need. Now, if I'm taking a database, for example, let's say this has thousands of people's contact number value. Now, these thousand people's contact number, I already told you all. If you all have any reactions, keep your reaction for the last with yourself. If you want to express it, this is the last time I'll put you out. Mohammed, if this repeats from your end, I'll be putting you out of the meeting. Not only him, anyone else comes and reacts with some emojis for someone else's message, I'll be putting you out. The last warning. Okay. The third one I got for today. None more come, I'll put the fill out. What is in alphabetic order? In this book, it's like a dictionary. You know how dictionary works, right? All the words are there in alphabetic order, right? So likewise, in this book also, everyone's names are there in alphabetic order. So you can go and find their contact number like that. Got it? Anyways, coming back to the point. So what I was saying is, if you take here the area it's taken in our what you call environment, physical environment, if you take, you compare manual database and computer database. I can store all of your information I told you in a spreadsheet, right? After I have all of your details stored here, I can download this sheet, let's say. Now this sheet, when I download it, I'll be getting here a file, right? Okay. This file I can even go and store in memory card. This whole file, let's say this file has around millions of people's data, millions of people's contact numbers. I can store this in a small memory card. But if I'm going to have a million of people's contact number in a book, will it take the memory card space or will it take more than the memory card space in the environment? For example, I'm going to keep both in the table. So if I'm going to keep the memory card in the table and the manual database in the table, will it take equal amount of space or will this manual database take more or less? Exactly. This is going to take more space in the physical environment. Perfect. It's going to take more space in the physical environment. Okay. So in that case, what happens is, what do you call in that case, what happens is you can compare and tell in a computer-based, computerized or computer-based database, it takes less physical space. Again, physical space means your space in the environment. Okay. Takes less physical space. And for manual database, you can mention it takes more physical space. Now tell me, out of both, which is comparatively more secure? Exactly. Now, for example, I had a spreadsheet which I downloaded a while ago. I had a sheet which I downloaded here a while ago, right? Yeah, I downloaded this sheet a while ago, right? Now, this sheet which I downloaded a while ago, I can put a password for that sheet. In computers, for every files you have, you can put password. But if I have a book like this, can I put a password for this book? Is there any way I can protect this book from someone else opening? No. Okay. So normally, comparatively, if you take a computerized what do you call database, this is more secured and this is less secured. Again, people can break that box now. Okay, so that's more secured and this is less secured. And then in terms of what you called access speed, size, security, and then in terms of let's say computers can be hacked. So what is the probability? What is the probability? What is easy? For example, you have all of it. For example, in your school, you all have this one, right? In your school, in the office, you will have a database in of your students' details, right? And in your classroom, your school register is there. Which one can you go and obtain the details easily? Let's say if you want to find someone's address or contact number, can you hack and take from the office easily or your register easily? Register. At least do you all know to even hack the system? At least access the system. Hack කරන්න ඕනේ ලං වෙන්නවත් පුළුවන් ද ඔයාලට? එතන බෑ. Computer based system is more secure. You can't access it. Okay. Time management, there is no much difference. Both take same time to store data, same time to store data. Only retrieve data is different. That's why I said it takes time to retrieve data, and you can easily retrieve data. Credibility wrong because both of them are okay. Accuracy, there is small difference. You can tell computer-based system is more accurate, but that's a mixed question. Like for example, in computer-based system, there are less mistakes you might make, but manual system there are more mistakes. What I mean by mistakes is sometimes you're not going to find someone's contact number. In a manual database, you might go through the list, and let's say there are two people with the same name. So if two people are there in the same name, there are possibilities you could make errors, and you could what do you call tell the wrong person. Or sometimes, for example, you're going through a name list. So when you're going through a name list, what happens is sometimes there'll be two names. Here there'll be Amal's contact number. Here there'll be Amala's contact number. Okay. So when giving the contact number, sometimes let's say you're going to find Amala's contact number. By mistakenly, a human error, you could give Amala's contact number. Because as close by, when reading, sometimes you might read the below row or above row. So human errors are possible. Then why does meteorological department records manually and store in a box? Who said they store manually and store in a box? Efficiency is about retrieving data. Efficiency in retrieving data, no. Database doesn't need internet, right? And if it's in PC, who said it needs electricity? So who said it needs internet? In your computer, there's a software called Microsoft Excel, Microsoft Word. Any software you can go and store. You don't need internet for that. If you want to make it cloud-based, you need internet. If it's going to be without cloud-based, you don't need internet. If I just try that computer-based is efficient and manual is not efficient, will I get marks? You will get marks, but to be precise, the most suitable answer is efficiency in retrieving data and inefficiency in retrieving data. So if you what do you mean by efficiency? Efficiency is you can do something quickly. So what can be done quickly here? Retrieving data can be done quickly. Apart from that, there is no other places where efficiency is going to help. Got it? So computer based is accurate enough. Not that it's accurate, less mistake. We don't say accurate, we say here it's less mistake and there it's more mistake. Correct. Here you can say easy to analyze data because it's in a computer, you can analyze data easily. So easy to analyze data. And here you can mention difficulty in analyzing data. Okay, is this clear all of you? Up to here? Okay, so basically, the grade 10, we have two, this part is for grade 10, grade 11 both actually, but we did not complete this yet, no. So the next one, I'll be giving a small half an hour, 1 hour break. That's at 7:30. So from 7:30 to 8:30, I'll be discussing this part as well. So the grade 10 students, I want you to join till 8:30. Grade 11, you all can stay after 8:30 as well, where I will be discussing. It might go actually until 9, I guess, but yeah, the grade 11, I want you to stay after that as well because I'll discuss HTML questions as well. Grade 10s, there'll be a small break after the break join. Anyways, until 7:30, there's a break. Those who have any questions, you can stay and ask. Others, you can leave and join the session 2. Session 2 link, I'll be posting it on the WhatsApp channel. So if you're not there in the Master ID WhatsApp channel, just drop a WhatsApp message to this number, ask in the channel link, and I will share the link. I know you'll have a seminar, math seminar. If you all want, join that or join this, your wish. That's construction, I mean, Baba stuffs. What time the grade 11 start? Grade 11 has to be there in that part as well. So you'll have to join at 7:30. Both of you have to join at 7:30. Okay. Will you upload the recording today? Yes. Actually, it's already there in YouTube if you go. Say that to Rizlan. I can tell you, no problem. I know, I know, if you're alone, I know, I can give you exactly what is he going to do even. The answers, not the questions. I'm pretty sure I might have the answers of what is he going to do. Let's see. I should have. This is one of the construction he's going to do. The construction number 4, construction number 6, construction number 5. These are the construction he'll be doing. These are first, see, wait and see. These are first construction he will be doing. I can give you all these notes if you'll come. Break is already started. Until 7:30, you'll have break. What time will you give break? Yeah, no. Will you do any recap sessions? This is basically I'm recapping the whole lessons, man. What is relevant for exams? No, man, this is my handwriting. This is what I wrote. What is that story of blah blah blah? Eh? That bug is jabbering, Sad. Same link. Ah, no, the link will be different. I'll be sharing the link in a channel. So just check out the channel. Page 1 and 2. Yes. This is page 1. At what time will the class finish though? Grade 10s, it will finish at around 8:30 to 9 between that time. Grade 11s between average 11 o'clock for grade 11s. And I am only speaking, I mean, I have to be worried. Why are you all worried? Basically, before you have 1 hour time, right? Below the before the next session, try doing the spreadsheet and database questions alone. So it'll be helpful for you. Can you give the ASCII explain ASCII code conversion? Ah, yeah, I can do. Hey, you stay. Just give me 5 minutes. I'll quickly pray and come and I'll explain you. Just stay now and just give me around 5 minutes. I'll come and explain. Hey, what's up in the way, by send me the paper, this number. Let's see. Will I be able to get the other part recording? I mean, after the break. Yeah, yeah, yeah. The whole full things recording will be sent to you. Ah, okay. Once you get it, send it. Because done. This is the second page. How's your throat now? That is dancing. You might not in the middle. I go and cough and gum because of that only. Okay, perfect. Others just do this question. one of you want the ASCII part. So not exactly. It's not about the pain. It's about the cough. It's I have wound in the throat. So when something touches that, I get cough, like any dust. Anyways, what do you call? I'll be explaining ASCII in another 5 minutes. So until 7:30, this meeting will be running. If you all have any questions, you all can ask any amount of questions. But there will be a small 5 minutes break, pray and come. At 7:30, the meeting will change. Can you explain about primary key, composite key, coding key, blah blah blah? In which situation? That I'll be doing when I explain this question. So stay. I'll be doing that when explaining this question. Question number 7. Okay, I'll explain that ASCII in the 5 minutes. I'll quickly pray and come. Just give me 5 minutes. Others, if you have any questions, drop your questions in the chat. I'm making the chat private, so you can send it to me privately in the chat. I'll come and check. And after the 5 minutes, I'll come and explain your ASCII. Yes, Abdullah. Okay, Akit, me, are you here? You're the one who asked the ASCII question. Akit, me, are you here? Shahz, at least join at 7:30 and cover the 6 and 7. Oh, wait, tomorrow different exam, no? Then you can watch the recording. Okay, let me start. So regarding ASCII, before I talk about ASCII, I'll tell you why are you learning ASCII, William? If you take your computer, we have different characters, no? Like letters, symbols, images, all of these are processed by the computer. But the one thing you know is the computer can understand only what you called computers can understand only binaries. So there should be a way how we can represent letters in binaries, how we can represent symbols in binaries, how we can represent images in binaries. Because only if you can represent the symbols, letters, images, sound, everything in a computer, what you do. Only if there's a way to represent them in binary, okay, only if this can be represented in binary, we can expect the computer to store them as well as we can expect the computer to process them, okay, or do any task using them. But if the computer can't understand letters, symbols, and images by default, whatever you type, then we can't expect the computer to work how we want, right? So what we have to do is these hardware engineers, what they did is they created something called as coding systems. Now, initially when computers were created, they just wanted the computers to be able to deal with numbers only, right? For example, initially when the computer was created, the one of the main purpose they were expecting from the computer was for calculations, right? So early days, even some people used to call calculators as computers because their main objective from a computer was to perform calculation because that was one of the biggest tasks which was difficult for human, right? So what they did is they wanted to represent these numbers in the computer, right? Now, what are the numbers we normally use in our day-to-day life? What is the name of the number system of the numbers we use in our day-to-day life? Learn about different number systems like decimal, octal, binary, hexadecimal. Out of this, exactly. Decimal is a number system which we use in our day-to-day life, which is having the numbers from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So using these numbers only we perform the calculation of, for example, if I say what is 93 times 5, you'll use these three numbers and write the question 93 into 5, right? So in the computer, we wanted to represent these decimal numbers in binary. So like basically use the computer to perform. For example, I want to use the computer and perform this calculation, right? So in that case, I have to tell the computer the two numbers, no, that one of the number is 93, the other number is 5. The problem is these two numbers at the moment they're there in the decimal form. So if the number is there in the decimal form, can the computer understand this number and perform the calculation? Is it possible? Can the computer understand decimal numbers and perform calculations? Yes or no? Directly, computer can't understand. What is a number system we know that the computer can directly understand? Perfect. The number system the computer can directly understand is something called binary. So if computer can understand binary directly, that means it for binary it doesn't need any processing. Okay, directly it can understand binary. So if computer's best friend is binary, if we can understand only binary by default, okay, can the normal computers be able to perform this calculation if it's in the decimal form? Directly, as a decimal number itself, can it perform the calculation? No, obvious no. Like for example, if I come and tell you all what is 5 times 5? You all know the number 5, you all know the number 5. So you all can perform the calculation till answer is 25. But if I ask you if I ask the same question in, let's say, a different language, for example, let's say in Hindi or Malayalam, or what do you call, Polish or Turkish, or if I use a different language and ask, now you all know how to calculate 5 times 5. But without saying 5 times 5, if I use a different language and phrase it, will you be able to do the calculation? Now, for example, let's say you don't know Sinhala. So if I ask her what is Paheva deka ki dekile, if I ask you all, will all be able to perform, or paswarak deka ki if I ask you all, will all be able to, sorry, paswarak paha deka paswarak paha. If I ask her paswarak paha ki dekila, and if you all don't know the language called Sinhala, will you all be able to tell me the answer? You all know maths, okay? But the thing is, you all don't know Sinhala. So in that case, what you will do? From Sinhala to English, what you will do? Exactly. You will translate. Okay, you will translate, right? Similarly, in the computers as well, what happened was, how will you translate? You will be like, okay, paha means 5. Okay, you will be translating. Hatara means 4. Likewise, you'll be translating, right? Similarly, in the computer as well, they had to translate each of these decimal numbers. Okay, each of these number, like for example, 93 to 5. When you say 93, this number 9 and number 3, it will be taken as two different numbers actually. It had to convert all of these numbers to binary. Okay, so the method we used to convert that from decimal to binary, we used something called as a coding system. Okay, like it's basically algorithm kind of scenario called BCD, which stands for binary coded decimal. So using binary coded decimal, you are able to actually convert only decimal numbers, which means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is not, 9 values are there, right? Only these numbers you are able to convert from decimal to binary. But with time, with the evolution of computers, did we use computers, or like, no, with time, the evolution of computers changed, right? So when you compare back then and let's say evolution up to today, was it a situation where computers were used only for calculation? Like computers were used only as a calculator. Is that how it's even now? No. Now we use computers for even to take photos, video calls, messaging, storing data, typing, several things we use. Okay. So there is evolution that has happened. So initially there was a purpose of only dealing with numbers. Then there was a situation they wanted to deal with symbols as well, like characters, like and symbol, star symbol, hashtag, at. Okay, they wanted to deal with star symbols as well. So in that case, BCD, using BCD, you can't do that because in BCD we created a system where we give a value for all these numbers, decimal numbers, but we don't tell what do you mean by star, what do you mean by letters, what do you mean by hashtag. We don't give. So that is where they create another coding system called ASCII. Okay. So in ASCII also there was limitations. So then they created another system called EBCDIC. This also has limitation. Then they created a system called Unicode. Right? Now, for example, I said about that English and Sinhala translation, right? If you take that translation, okay, how many different words you will have in Sinhala? I mean, in terms of the numbers, how many different numbers you will have in Sinhala? I mean, I'm talking about digits. I'm not talking about whole numbers. Like I'm talking about singular digits. If I'm talking about singular digits, how many digits you might have in your singular language, let's say? Like eka, deka, tuna, hatara, yela, how much you will be telling? Actually 10. Because bindu is also a number. So bindu, eka, deka, tuna, gila, will have 10 numbers. Now in Sinhala, if you're going to have 10 numbers, fine. English, how many numbers again you're going to have? Again, you're going to have 10 numbers. Okay. So you're going to tell here the meaning of bindu, you're going to tell the meaning of eka, deka, tuna, hatara, fine. Okay. So in this, in that initial situation I told you, you're just talking, you're learning some Sinhala words, right? You're learning only 10 words. Okay. I mean 10, actually 10 characters, I'll say, or let's say 10 words. In this syllabus, imagine this as a different syllabus, like a textbook. From this textbook, you're going to learn only Sinhala 10 words. Now, if you know only 10 words, if you get a question out of those 10 words, will you be able to handle it? Exactly. Out of those 10 words, if I use any other words, you'll not be able to handle it. Why? Because you have by heart only 10 singular words, right? So in that case, what happens is if you take BCD, it uses only for decimal no. So in BCD, it in that language, it was able to translate. It took only 10 different characters. It translated this 0 to binary, this 1 to binary, this 2 to binary, this 3 to binary. It translated only these 10 characters. So apart from these 10 characters, if you give any other characters, if you go and ask, okay, what do you mean by, let's say, A? It'll be confused. Like, A, yeah, what is A? It doesn't know how can I represent A in binary. It doesn't know. So with time, what happened was this fellow was able to represent only 10 characters. Okay. In ASCII, what happened there was we were able to represent 2 to the power 7, which is actually 128 characters. But again, with time, this 128 was not enough. Then ABCDIC came. Here we were able to represent 2 to the power 8 characters, which is 256 characters. With so this what I mean with characters means like A, B, C, D, E, F, G. These are all one character. 0, 1, 2, these are characters. And star, hashtag, at these are all different characters or symbols, right? So Unicode, what happened was this 256 was not enough. Here we came with 2 to the power 16. That is 65,000. I think 546. 2 to the power 16 is equal to 65,536. Sorry. 536 different characters can be represented. So currently the 65,000 is more than enough. Like for example, if you take each and every unique English alphabet, single alphabet, Tamil alphabet, Chinese alphabet, kila, Okkumarang, if every emoji is kila, if you take every character that you can see, everything you can see in the screen in terms of characters, like you can type using the keyboard, here these characters. No? If you consider each and every character, mostly the 65,000 is more than enough. Okay. So basically, this is how these different coding systems were created. So if you take BCD, it can represent only decimal numbers. ASCII, it can represent decimal numbers as well as letters and certain symbols. ABCDIC, again, letters, numbers, more symbols. Unicode, letters, numbers, symbols, colors, everything can be represented. Nowadays, we use Unicode only for the coding system. Is this part clear about coding systems? Like the origin of those? Okay. Now I told you about BCD, ASCII, EBC, Unicode, all these stuffs, right? All of them had a common purpose. We are going to represent something in what? The only difference between them is the number of characters. BCD had only 10 characters. It knows only 10 characters. ASCII knew 128 characters. EBC 256, Unicode 65,000. Exactly. All of them had a common purpose. But why were all of them created? To represent something, okay, to represent something in binary. Now, when you're representing something in binary, there has to be method to be followed. There has to be method. Without a process, you can't represent anything and everything in binary. No. So what happened is in BCD, let's say you had a character. For example, let's say someone came and told you, this is a BCD value. Okay. Or no, so not the BCD value. Let's say someone come and asked you, okay, we have a number called 27. Please represent number 27 in BCD coding system. Okay. Now, when you want to represent something in BCD, how BCD was created was BCD was like, okay, let's assign to represent one character. Now, this is one character and this is another character. Okay, these are two different characters. So how BCD was created was like, let's represent each character using 4 bits. What do you mean by the word called bits? What does this word called bit mean? What digits? Correct. The word bit means binary digit. So we are going to see how can we represent number 7 using 4 binary digits. How can we represent number 2 using 4 binary digits? So there's a method which you follow, which just write like this. I'm not going to explain this in depth, but there's a method you can follow. And to represent number 2, you need only 2. To represent 7, you need 4 plus 2 plus 1. 1, 1, 1, 0, 0, 1, 1, 0, 0. So technically, the answer of 27 in BCD is going to be equal to 0010 011. ASCII, I will show you how to do the process, but BCD we do not want to. So this is how we represent number 27 ASCII. So in BCD. So this will be the binary number representing 2, and this will be the binary number representing 7. So the same method only was followed for other conversions as well. Now in BCD we represented each character using 4 bits. So what happened in ASCII was, in ASCII we represented each character using 7 bits. So for example, if you had number 27 like this, what happens is you represent number 7 using 7 bits and number 4 using 7 bits. If you want to convert this to ASCII, 7 bits. So how do you do that is actually, if you want to convert a number from decimal, if you want to convert it to the 7 bits, right? What you do is you write the first 7 bits place value. There is 2 to the power 0. Like now, for in decimal numbers, you all know ones place, tens place, hundreds place, right? Similarly, you write the binary numbers place value. That's 2 to the power 0, 2 to the power 1, 2 to the power 2 kilo, 1, 2, 4, 8, 16, 32. So that's going to be basically 1, 2, 3, 4, 5, 6, 7. I'll just don't space it, so I'll write it down. Okay, there's no space here. No? So if I'm going to write it down, 27. That's going to be basically 1, 2, 4, 8, 16, 32, 64. 1, 2, 4, 8, 16, 32, 64. Now to form the number 2, we need only 2. To form the number 7, we need 4 plus 2 plus 1, right? So these are basically two different place values. I wrote the first 7 place values of binary I have written here, right? Below the numbers, we need write 1. Below the numbers, we don't need write 0. And join them together. So number 27, if you represent in this number 27 in ASCII, it will be basically 1, 2, 3, 4, 5. You don't have to keep a space. I just keep a space for visual cleanliness. But we write all of this together, okay? So this is the number of 27 in ASCII, where these will represent number 2 and this will represent number 7. So this is basically how ASCII works. Yeah, that's fine, Ashwati, no issues. Okay. Yeah, so what is ASCII is basically it's how you represent what do you call numbers in 7 bits. I'll show you a question type how ASCII comes to you all. But before I go for the question, tell me, did you understand this portion? But I thought you're here. Jamila, I'll show it. Okay. Now, when you get questions regarding ASCII, how you all might get questions regarding ASCII is you'll be getting questions like this. They'll be asking you a question such that, okay, we have this number called, we have this word called, what do you called? Where? We have this word, there's a word called, what do you call, cab. And the question will be like, how can you represent the word called cab in ASCII? They ask you to convert, what do you call the word called cab to ASCII, right? Now, at the end of the day, our job is basically to convert these values to binary, right? Where the letter C is represented using how many bits? Correct. Letter 7 is C is representing 7 bits. Letter A is represented using how many bits? Like by bits means binary digits. How many binary digits? Perfect. Again, we need 7 binary digits. And to represent letter B, how many bits we need or how many binary digits we need? Again, same thing. We need 7 bits. But now we have a problem. Okay. I told you how you do this is basically I write this 1, 2, 4, 8, 16, 32, 64. What I've done here is the first 7 bits place values. Okay. If you're wondering how I got this 1, 2, 4, 8, it's basically 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Kila. The first 7 binary digits because I want to represent number in binary 7 binary digits. No. So the first 7 binary digits, they are placed when I wrote here and I circled. Now, if it's a number, I can find the value directly. Right? If it's a number, I can find the value directly now. But what do you call the problem I have here is if it's a letter. Basically, this method is not complete. Huh? I'll come to this in a while. If it's a letter, I have a problem. For example, if it's, for example, like the word A, what do you call it, say cab, the problem we have is, does the letter B have a numeric value? We are here talking about we don't know. No, we don't know. No, cap base is not a hexadecimal number. Huh? We're not talking about hex. If it's a hexadecimal number, yes. If it was cap base 16, yes. But did I write cap base 16 here? No. I told you cap is a word. If it's a hexadecimal number, then you can say yes, in hexadecimal there's a value. But if I just write this word called cap, does the word called cap have a numeric value? It does each of these letter have a numeric value? No. So there was a problem they faced here. They were like, okay, numbers we can directly do, but how about letters? Then they were like, okay, let's do something like this. For every number, sorry, for every letter, for every symbol, and every what you call other characters we have, let's assign a number. Okay, let's assign a number. So what they did is for the capital letter A, they gave a number called 65. Capital letter B, they gave a number 66. And likewise, the numbers kept on increasing. For simple letter A, I think it's 95 or 93. Uh, it's 97. Sorry, 97. Okay. Simple letter A is 97. Okay. Now, if you're wondering who gave this, who told that, okay, A has to be 65, B has to be 66, C has to be 66. If you're wondering who told that, that was given by an American institute called as ANSI. American National Standard Institute. This was a person, this was a what you call organization that came and told, okay, what do you call, let all the, this ones, let all the, what do you call, the numbers, these are the values you have, killer. They came and formulated it. Is that part clear? Did you understand what happened? What was the problem faced and what was the solution like they gave? Okay, perfect. If you have any questions, ask. Huh? So now what happened was they made a standard like a dictionary kind of thing. Every number they made like a standard dictionary kind of thing. And they told this number, this has to be the value. This number, this has to be the value. This number, this has to be value, the value killer. They told. And then give me a moment. Yeah. Now let me tell you how you do questions regarding this. Mm. So I told you there was this organization called American National Standard Institute, which gave a value for every number, right? So based on what I told you a while ago, tell me what was the value they gave for the capital letter A? Correct. They gave the capital letter A as 65. And I told you these values increase what you call increment. I mean, what you call in a step-by-step manner, like in a what you call in a arithmetic progression, it increases. So based on that, tell me if A is 65, now we have to find for cab, no. So cab means we have to find B and C as well. What is the value of C? What do you think C would be? Perfect. C would be 67. And B would be 66. Now, if we have assigned a value like this, 65, 67, now can we find the binary answer directly? Can we convert that answer to binary? Yes. So we call this 65, 66, 67 is that we call this as the ASCII value in decimal. The ASCII value of a character in decimal. Now here ASCII is in decimal. But when you're representing to the computer, can we give these decimal numbers for the computer again? Will the computer be able to understand 65, 66, 67, even though it's an ASCII? But will it be able to understand these decimal numbers? No. So we are a basic, now we should, what we should do is we are to convert this to binary. So what you're going to do is you're going to find out, okay, how much is 65, how much is 67 in binary in 7 bits, how much is 65 in binary, how much is 66 in binary. There is two methods for this. One is a method two, which I was showing you all this time. Actually, I should have showed you the method one first. I'll just show the method two again. Method two is very easy, basically. That's why I use that. What you do is you try to represent this whole thing using 1 to 4 8 kind of scenarios. Like, for example, imagine you have here 64, 32, 16, 8, 4, 2, 1. 1, 2, yeah, 1, 2, 4, 8, 16, 32, 64. Always it will be 1 to 64 only because 7 bits. 1, 2, 3, 4, 5, 6, 7. Right? Now, to form 65, okay, what is the largest number we need here? Out of 1, 2, 4, 8, what is the largest number? Correct. We need 64. So below 64, write 1. Now, how much more do we need to get the number 65? We have 64. 64 plus how much is 65? Plus 1. So below 1, write 1. Below the remaining, write 0. The ASCII value of 65. Similarly, let's 4, 5 for 64, 66. Out of 1 to 4, 16, 32, 64, what is the largest number that is equal to 66? I mean, that can be used to form to 666. The largest number is 64. Okay, if I use 64, balance how much I need to form 66? I need 2. So below 2, write 1. Below the remaining by 0. Done. Now, to form number 67, what is the largest number I need? 64. So below that, write 1. To form number 67, how much more I need? 3 more. To form number 3, what is the largest number I have? 2. Okay, so now 64 plus 2 is 66. How much more I need to form 67? I need 1 more. So below the numbers I need, I wrote 1. Below the numbers I don't need, I wrote 0. So 65 is equal to, so basically 65 is A now. A in ASCII is equal to 1, double 0, triple 0, double 0, 5 zeros, 1. B is equal to 1, 2, 3, 4. And C is equal to 1, 2, 3, 4, 5. So the ASCII is going to be this whole thing. You don't keep a space now. You write all of them together. But to differentiate, I kept a space. This method is the easiest method. But did you understand what is happening here? Now I'll show you all the method one, which is mostly done in schools and wherever you go. Okay. Method one is where you convert each of them from decimal to binary. Because this 65, 67, I told you a while ago, these are the ASCII values in decimal, right? So to find out what are these ASCII values in binary, that is to take 65 and convert it to binary. That's divide by 2. 2 times 32 is 64, 1 remains. Divide by 2, 2 times 16 is 32, 0 remains. Divide by 2, 2 times 8 is 16, 0 remains. Divide by 2, 2 times 4 is 8, 0 remains. Divide by 2, 2 times 2 is 4, 0 remains. Divide by 2, 2 times 1 is 2, 0 remains. Divide by 2, 2 times 0 is 0, 1 remains. You do the division until you get 0 in the bottom and write the answer bottom top. That's equal to 1, 2, 3, 4, 5, 6. See, the same answer only we got. But what do you think was fast? Method 1 is fast or method 2 is fast? Exactly. So if you all are familiar with whatever you all want, you all can choose. That's your wish. I am lazy, so I'll go with method 2 always. But yeah, both of the answers are correct. So same thing if you go and find out 66 and 67, you get the same answer. Divide by 2. 2 times 33 is 66, 1 remains. 2 times 15, 16 is 32, 1 remains. 2 times 8 is 16, 0 remains. 2 times 4 is 8, 0 remains. 2 times 2 is 4, 0 remains. 2 times 1 is 2, 0 remains. 2 times 0 is 0 only means. Write the answer from bottom to top. You get 1, 1, 2, 3, 4, double 1 base 2. That same thing we got here as well. Correct. This is how you can ask a question. So if they ask you to represent cat in as cab in ASCII, you can be like cab is equal to this. They might give you a hint, I mean. They might tell you, okay, A is 65 or B is 66. Some hint they might give you. So using that hint, you can find out the remaining letters. And after the remaining letters, whole thing is called the value of cat. Okay, it makes it clear. If you have any questions, drop in the chat. Others, you don't have any other questions? Ah, Jamila, you asked the question. But before I go for Jamila's question, anyone have any questions regarding this ASCII? Anyone having any questions? Okay, I'll go for Jamila's question then. Your question was, I got a question from my teacher to 24,000. Is it 24,000? 2,400 GB? Wow, what a number to convert to bits. These are called data storage units. So when you're storing data in the computer, what do you call? Like I told you a while ago, computers can understand only binary. So everything is basically based on binary. So we are going to talk about how many binary digits we need. Simply how many binary digits we need in order to store a file. Okay. So the problem is when the file size is bigger and bigger and bigger, we're going to get a very large number. Like for example, imagine you have a 24 GB file. So this is 2004, we're going to get a very big number. Okay. Imagine you have a 24 GB file. Writing 24 GB in bits, it's going to be a very large number. Okay. So what we do is without mentioning these numbers in small units, we started giving new names for new units. Like for example, we have this measuring unit called millimeter, right? Imagine we are going to measure two roads in millimeter. Is millimeter suitable, what do you call, measuring unit to measure roads? No. What do we normally use when we're measuring roads? Shima, no. Mostly no. But if you get the process is same, mostly we use kilometers. Okay. If you're wondering why aren't we using millimeters, the reason is because sometimes if you to mention two distance, let's say you're going to mention 10 kilometers, that same 10 kilometers, if you're going to mention in millimeters, it's going to be a very huge number. Okay, the same 10 kilometers, if you're going to mention in millimeters, it's going to be a large number, right? So therefore, without going for the smallest measuring unit, we started creating different measuring units. So what we did is from bits, the next largest measuring unit we had was bytes. Then we had something called kilobytes. Then we had something called megabytes. Then we had something called gigabytes. Then we had something called terabytes. And then we had something called petabytes. There are more. In your syllabus, normally we stop with petabytes. So yeah, okay. So if you're forgetting these words, the odd or something, there's a stupid formula I made which doesn't make sense. But if you all want, you all can remember that like big brother Ken made green to purple. It doesn't make sense. But if you can remember the order, you'll keep it in your head like B B B K M G T P. See, B B B K M G T P. So your wish. Anyways, so you all have to make sure you all know these names, right? So units for bits is simple B. Units for byte is capital B. Kilobytes is KB. Megabytes is MB. Gigabytes is GB. Terabytes it's TB. And petabytes it's PB. Okay, so second thing you have to know is the units. Now we come to the conversion. Before I come to the conversion, just tell me in a company, let's say you're working, right? Let's say you got promotion. Now, will your salary multiply or divide? Like multiply means increase, divide means reduce. So, will when you got a promotion in a company, will your salary multiply or divide? No, Uzair, that will be in different meeting. There's 10 more minutes for that. Exactly. Your salary will multiply. Now, if you get demoted, like if your role go down, let's say you have some mistake and they're going to put you down. Now, does the salary get multiplied or divided? Now it's going to get divided. So keep this idea in your mind. Okay. When you're going up, you're going to multiply. When you're going down, you're going to divide. Second thing is every step you're going to go, you're going to deal with the number 1024. Okay. For every conversion, you're going to deal with 1024. But whenever you come across a word called bit, if your conversion has a word called bit, then instead of using 1024, use 8. I'll explain what I mean. For example, let's say you're going to go up. That means you're going to convert from petabyte to terabyte. You're going up, right? So to multiply. Multiply by how much? 1024. Convert from terabyte to gigabyte. Multiply. Multiply by how much? 1024. Let's say you want to convert from gigabyte to megabyte. Again, multiply. Multiply by how much? 1024. Let's say megabyte to kilobyte. Multiply. Multiply by how much? 1024. Kilobytes to bytes. Again, multiply. Multiply by how much? 1024. And bytes to bits, that's what you're going to multiply. Multiply by how much? 1024. So whenever you're going up, you multiply by 1024. But there's a mistake I did here. What is the mistake I did here? Based on the explanation I told you. You should notice I did a small mistake. What is the mistake? I told you when I'm converting, if I come across this word called bit, then what is the number I have to use? 8. Now, if I look at this conversion, okay, if I look at this conversion, here I'm going to convert from kilobytes to bytes. Is a word called bit there? Kilobytes to bytes. Is a word, am I pronouncing the word called bit? Kilobytes to bytes. Kilobytes to bytes. Am I pronouncing? No. So therefore, I'm going to multiply by 1024. From here to here, bytes to bits. Now am I pronouncing the word called bit? Bytes to bits. Yes. So to multiply by 8. So when you come across a word called bytes or bits, you make sure you use the word 8 or else 1024. Now similarly, when I'm going to convert, let's say from bits to bytes, what should I do? Going down. Exactly. Divide by 8. And then bytes to kilobytes, what should I do? Shima, tell byte. Correct. Here I have divide by 1024. So all these steps divide by 1024 because you're going down, divide. And I said when the word called what you call bit is there only, you have to put 8. Others all the situation you divide. So divide by 1024. So this is what's going to happen. Now let me tell you how this can be applied in a question. Okay. Before I come to your question, I'll show another question, right? So for example, let's say we had a question like this. To convert 2 MB to KB. Now MB to KB, you can see it's here now. This is MB and this is KB. We're going to go from MB to KB. To go from MB to KB, are we going up or down? To go from MB to KB, up or down? We're going up. So we have to multiply or divide? Multiply. Multiply by how much? 1024. So how many MB we have here? 2 MB. So if you multiply the 2 MB by 1024, you have 2 times 1024. You can write the answer as 4,000. So 2048 kilo, you can write the answer. But normally now what you call in conversion questions, we don't write the answer like this. Okay, we don't write the answer like this. Normally what we do is we keep them in index form. That's basically 2 to the power 1 into 2 to the power 10. So in maths, you all know if the base is same, you can add the index. So that's going to be 2 to the power 11. Is this part clear? MB to KB is decreasing, right? No. See, we're going up. Look at the chart I'm saying. See, this is MB, this is KB. So MB to KB, you multiply. Value is decreasing, fine. So for example, 1 centimeter. If you're converting 1 centimeter to millimeter, millimeter is small, but 1 centimeter is equal to how many millimeters? 10 millimeter. See, we are multiplying by 10. Okay, got it? Should we have the power form? Small questions you don't need, but large questions you need the power form, or else you'll have a very big number. Now let me go for the question which you asked. Okay, what was the number you asked? 2400 GB. Now tell me, to go from GB to K bits, is it one step up? No. First of all, you have to convert what? You have to convert the number in GB to the MB. Then you have to convert the MB to KB. Then KB to bytes. Then bytes to bits. The how the conversion should happen now. Okay. So to convert from GB to MB, you can see here, are we going up or down? Correct, up. So you're going to multiply by 1024. Same thing, MB to KB going up, so multiply by 1024. KB to bytes going up, multiply by 1024. From bytes to bits, what should we do? Yes, we're going to multiply by 8 because here we have the word called bits. You're going to multiply by 8. So if you do this, the answer is going to be something like this: 2400 into 1024 into 1024. Okay. Into 1024 into 8. Now, one of you will ask, should we keep in the index form? If you're going to multiply this, the answer you're going to get, is it very easy to write in a long answer? No, right? So that is how you go for the index form. So you can represent 24,000 as, for example, um, 2 to the power, let's say 8 times 30. Or we can mention, the smallest we can mention is, let's say, uh, I'll keep 2400 as it is, wait. Okay. But this 1024, I can represent in 2 to the powers, right? So I can represent this 1024 as 2 to the power 10, 2 to the power 10, 2 to the power 10, 2 to the power 3. So the base is same, you can add them together. That's 2400 into 2 to the power 10, 20, 30, 33. You can keep your answer like this as well. You can keep your answer even in this step, like here you can stop. But you can simplify 2400 as 2400 is normally equal to the index form. If you're going to write, you can write it as um, 2 times 1200. So 1200 you can write as, sorry, you can write 8 times 300. That's basically 2 to the power 3 into 300. No, that's 2 times 150. That's 2 to the power 4 into 150. Is there any other way you can shorten that? You can write that in index form. I'm not sure what the exact smallest number, do the LCM and HCF and all those stuff. But I'm going to just keep the answer like this. You can stop your answer like this. But anyways, this is where how you find the answer. Got it, Jamila? So when you get a question, just draw this whole chart, bits, bytes, kilobytes, blah, blah, blah. Up is 1000, if down is this one. And then start doing the question. Mhm. Okay, I have shared the session 2's link in the channel. I'm going to start it now. Join the session 2 now. Okay, you can ask me any questions there. For 200, 2400, there is no fixed power. I don't know. It should be some, maybe you can write that as 24 into 10 to the power 2. So 24 you can write as 8 times 3. So that you can write, for example, as let's say 2 to the power 3 into 3 into 10 to the power 2. That's like, for example, uh, 3 times 10 to the power 2. 3 into 10 to the power 2 into 2 to the power 35 or something. So it's that's mathematical part. You can't in 2 to the powers. I think the maximum you can represent. 2 to the 2 times 5 you can represent this as. You can represent this as 2 times 10 to the power 2 is 100. No? Yeah. 100 you can represent as 2 times 50. So you can write that as 3 times this you can represent 50. This you can write as 2 times 25. So 3 times 25 into 2 to the power 37. I think the shortest you can do is 3 times 25, but that's unordered. That's maths basically. You don't need to do those steps. I mean, that's what I'm going to do now. Next. Okay, the session 2 link is there in the channel. Okay. I'm going to start that session. I'll just share that link in the chat as well. Click on that link and join because we're going to start the session now. I'll end this meeting and start that. So leave this and join there. Okay.